Today we are going to discuss about the next talk that would be related to forecasting techniques. So basically we have discussed so far what are the renewable energy sources are available and how we can employ the machine learning particularly for sustainable development. So in this uh, talk, we'll see how we are going to utilize. So forecasting means we are going to just predict the informations with the help of some historical data. Okay, so the prediction part also would be there, but in that two cases, we are going to see how we can deploy the various methods in terms of machine learning, in terms of deep learning, and we can get it the informations related to renewable energy resources. So according to the talk, we are going to discuss about how time series data we can utilize for forecasting models for especially for solar and wind power. So we have solar and wind powers are there. These are the renewable energy resources is available. So we can utilize this data. Particularly, we have to develop the forecasting model. Also, we have various probabilistic based model. So probability theory will be utilized. Probabilistic forecasting methods, especially for in energy management. So also we are going to see implementation various forecasting algorithm. So in our practical part, we have discussed about how we can utilize Python are also one of the language. We can use forecasting algorithm using Python and other languages either R or some different languages also available. And also we'll see at the end future trends and challenges. So according to the talk, how we can just utilize the particularly importance for forecasting in terms of renewable energy resources. So far we have seen we have multiple resources are available like solar energy, wind energy. So efficient energy distribution is very important and we are going to provide the power with respect to grid. So grid stability also one of the important aspect for us. So accurate forecasting is allows energy providers to predict how much energy will require. That means how much energy we need to generate, how much energy we need to transmit, and it will be utilized. So whatever the energy is available, but we have to predict with respect to various mathematical model or various machine learning or deep learning based techniques. So how much energy will be available at particular given time and how much energy is required to generate. So with respect to future data or with respect to future aspects, we are going to analyze that. So we are going to ensure that energy supply can meet with respect to demand. So whatever our demand will be there, so as I told in the my first session, as we require more and more energy because our power consumptions are increasing day by day, our devices are increasing day by day, so demand also are increasing day by day. So we have to work, we have to ensure that whatever the energy is available in future, that will be utilized by the proper way or not. That means the demand will be satisfied or not. So there is a we have to ensure that energy supply can meet the demand, and also we have to reduce the risk particularly for blackouts or energy shortages. So it should not happen. So also it helps to balancing the grid by integrating the renewable energy resources. That means we can balance the grid by applying of various renewable energy resources smoothly with traditional power plant. So traditional power plant we are going to deploy with smart power plant or smart grid. So all these are the possibility will be there when we are reducing the reliance on fossil fuels. As I already explained, by predicting the availability of renewable energy, how much energy is available, how we have to generate with respect to availability and with respect to demand. These are the two factors are there. So energy providers has to work in this direction. They have to minimize particularly need to fall back on fossil fuels based on the power generation. So how much power is going to how much power is already available and how much power is already that going to utilize. So this is not help to reducing the greenhouse emissions, but also promote the use of cleaner and sustainable energy resources. That is the main important part. That means how we are going to work under the forecasting. So forecasting area will support energy traders and market operations. They are very important part, because as we are promoting certain technology, the market people want to that means deploy this technology to the particular user point of view. So forecasting allow the energy traders to make, that means inform the decision about the buyers, how many buyers are there, how much energy is going to be sell. These are the more important part for the support of the market. So accurate predictions of energy generation is very important. Consumption also very important. That help in setting the prices, because how much energies are available and how much energy are going to supply to the users. That will be very important part, because based on that the price will vary. Okay, so price is increasing if the availability is more, and whatever the energy is available, that is very less. So in that case, the market people has to increase the price, because of the consumption is going to be more. So related to the market people, they are setting the prices, enabling the efficient market operations and financial planning. So another factor, enhancing the decision making for energy policies. So that's why they have to provide certain decision making policies. So policies makers can use forecasting method. Forecasting method, whatever data is available, based on that they will provide forecasting data to particularly devise the strategies and policies that encourage the growth of renewable energy. That means whatever the energy is, resources are available, and whatever the energy generation already going on, these are the two factors are there. That means if number of appliances are increasing, number of power consumptions are increasing, in that factors the particular market people are having the requirement to generate more power. So they have to rely on more renewable energy resources. So demand and supply, this is the two factor we are going to decide. But how? By forecasting. So forecasting is our requirement. So that means we have to set certain regulations, we have to set certain, whatever the development of renewable energy infrastructure is available, we have to improve it. So accurate forecasting, and also we have to aid the particular long-term planning. That means if you are not able to manage, that means we will reach to the crisis. Okay, so energy is already available less and consumption is very more. So that is the more important part. So sustainability goals we can reach once we'll employ this all parts. So enhance the decision making. So like that, solar and particularly wind power forecasting. So we have these two energy resources which are readily available. So solar power forecasting, that means predict the amount of electricity that will generated by solar panels. So how governments are initiating solar panels, how they are going to provide that, factors like sunlight intensity is available, cloud covers are there, geographic locations are there, seasons also there. So wind power forecasting, that may be predicted by amount of electricity that will be generated by the turbine, and it will be based on the factors. What are the factors are there? Wind speed is there, wind directions will be there, and turbulence will be there. So we can easily understand these are the two sources are available. Forecasting models generated, and continuously you have the data loggers. What data loggers are doing? The data will be generated through the different resources. So these are the two sources are there. Forecasting model will help how many energy has been generated, how many is required to generate. Based on the historical data, the energy will be predicted. That means energy demand is increasing, then more energy power sources need to be generated. More power need to be generated. If less power requirement will be there, they will generate whatever enough resources. So infrastructure will increase. Okay, so more photovoltaic source need to be increased, more turbines need to be increased if your demand is increasing. So this based on the demand, the forecasting algorithms are working and predicting and generating. So like energy management strategies also there that will be implemented, and based on that energy will be distributed to the particular area. That means the whatever the sources are there, power banks are there, battery banks are there, they are going to store. So this is the continuous systems working. So forecasting will be the one of the important part, but there are various challenges are there. That means high variability and uncertainty. As I said, solar energy, it depends on the climate conditions. So with respect to solar energy, solar power generation is highly variable due to the changing weather conditions. So weather is important factor for solar energy, such as cloud conditions or precipitation conditions or atmospheric particles. So intensity, whatever the sunlight will be there, that means also energy productions can fluctuate. So fluctuations are more when we'll talk about wind energy, speed of the wind will be there. That is the main important factor here over short distance or time period. So wind energy are working under different patterns. So wind patterns are more mainly influenced by the geographical features or seasonable changes also. Here also weather condition also important part. Even diurnal cycles also. So these all the making challenges while predicting the wind energy generation accurately. And also one more factor, limited availability of high quality historical data. As I said in the practical session, I told you should have the data. Without data, you cannot work. So you should have more data. So with respect to data has been generated by various sources. So historical data is very critical for creating accurate forecasting model. If you have created model with only 1000 data, that means if 1 lakh data will come, that model won't work. That is the main problem with respect to prediction model. So we have to work on many reasons. There are maybe lack of long-term high resolution data or solar radiations or wind patterns. So this is the one of the limitation. This is the one of the issue. Reduce the accuracy of prediction. So accuracy will decrease or it is a hinder of development of robust forecasting. Robust means under circumstances model must work. It must be robust. So various circumstances that will not allow to the work to develop forecasting models. So that is the main hinder this side. Are also influence of weather or climate change that I already said. Weather pattern also may vary. That is also playing a very important role for energy forecasting. Sudden and unpredictable weather event just like storms are there, cyclones are there or heat waves are there. It will disturb the energy or energy productions also lead to a significant forecasting error. Another factor is there running advanced forecasting model. That means we need to work advanced forecasting model that will be based on the demand. That is a significant on computational resources. That means whatever the computational resources, hardware requirement will be there. So high performance computing infrastructure is very important. Like GPU based system or high end workstation, many things are required to process the large data set. Otherwise you cannot run the simulation in the faster way. You cannot solve the problem in faster, generate the timely forecast. So this can be resource intensive process, especially for region with limited technological infrastructure. If you have limited infrastructure, that will be the another limitation from our side. Now what is the role of AI ML in particularly forecast? As I said, data will be generated and we are going to forecast. So neural network, already we discussed, will come under the supervised learning method. So neural network models or decision tree based classifier or convolution neural network, these are the architecture which are readily available. What is the process we are going to do? We are collecting data from various energy resources and we are providing the prediction model, we are generating the model, and also I said computational resources are very important. So these models mimic the human brain. That means we are going to design a machine. That machine will perform the task automated way. Okay, so same way what human are doing. So we are going to mimic the structure. That is the already neural network architecture will be there. And they are capturing the complex pattern in data. And what is the procedure we have? We have feature extraction. So before feature extraction, we are going to be pre-process the data. Pre-processing, cleaning of the data. If any missing data will be there, if any error will be there, noise data will be there, we have to improve it and make it suitable for further operation. After that, we have to extract the feature, which are important features, which are relevant feature, which are optimal feature, we have to identify by feature selection. After feature selection, we need to work on classification. Classification, who will do the classification? Neural network. Neural network or decision tree classifier or Bayesian classifier or support vector machine. So they are particularly useful for time series forecasting. Time series forecasting in renewable energy, that means data is generating with respect to time. We can say temporal. So with respect to time, data is generating. So today morning data has generated. Today afternoon data has generated. So we have the data with respect to time, that is called time series data. So time series analysis will take place, and where the past patterns also will be available. Past data will be available that will help for predicting of future trend. That is the main role of machine learning. That is the main role of AI for prediction of future. So like tomorrow, what will be the temperature of Warangal will be there. Day after tomorrow, what will be the temperature of Warangal will be there. Day after tomorrow, what will be the temperature of Mumbai will be there. So various sensors are working continuously. They are collecting data every day and giving that data to the model, either ANN, either CNN, and model is predicting tomorrow there will be possibility of rain, 80% chances, 90% chances, 70% chances. So various prediction method will work in that case. So likewise, decision tree model, tree-like structure. That means that is parent will be there, then child will be there, sub-child will be there. One direction you can choose one decision, another direction, another decision. So various decision can be obtained in terms of decision tree classifier, that is based on the decision of input features. So features is one of the important parts. We have collected feature, we have selected feature, and we have feed feature to the classifier. Classifier will be able to provide the decision. So they are excellent for understanding for various factors affecting energy production. So what factors are affecting to energy production? Weather is one of the factors, or different other factors are there. So that hinders we are going to avoid. So that is the main important part with respect to machine learning, that can handle both numerical data and categorical data. Numerical numbers data will be there. Categorical data means different attributes are there. So all attributes can be required to generate. Deep learning means we have 2 layer, 3 layer, 4 layer. We can say neural network, but more than 5 layer, 6 layer, 7 layer, 8 layer, 9 layers. So every layers are responsible. That means extracting of features. That is called feature learning. In convolution neural network, we have replaced the multiplication operation by convolution operation. So convolution means one matrix will be there, one kernel will be there. Kernel will just multiply this area. It will extract the feature of this area. Like this kernel will pass from left to right, top to bottom. That process is called sliding. Sliding process will take place. That feature will be extracted. And now various weights will arrive. During first operation, weight was W1, W2, W3, W4, W5, W6, W7, W9. 3 cross 3 kernel utilized. Now next iteration, new kernel will come. Next iteration, new kernel will come. Kernel will provide different weight matrix. And who is responsible to provide the weight matrix? Optimizer. So by optimizer, we are predicting different weights. And finally, we are mapping the output with respect to predicted output. So you have exact output and you have predicted output. Based on that, you are mapping. So if your mapping will take place, error will become 0. Loss will become 0. So our aim is by multiple iteration, we have to reduce the loss, improve the accuracy. That will be possible when we laid multiple layers. And every layers, there are multiple computational nodes are there, processing units are there, and processing units are responsible to extract the feature. So first layer, low level feature, then new some more layers, medium level feature, and last layer, high level features. High level features that is relevant to pattern, textures, but low level features that is relevant to color. What kind of color will be there? Blobs is there, edges will be there. So likewise, we will lines are there, multiple lines, multiple edges. All these are the low level features. So in terms of data, that is used for particularly image recognition. Image recognition means we are going to recognize the particular area, and area will be identified. So suppose example, one cat is there in a picture. So this area cat will be there. Remaining area is background. So this area more dominant features will come. That feature will responsible to recognize cat as a cat. With respect to feature of the cat, but replace the cat as a dog, feature will change. So the machine will recognize that is dog, that is not a cat. Understand? So that is recognition will take place by convolution neural network. So CNN can be adapted forecasting by identify the spatial pattern. Spatial pattern, that means directly values of weather data or cloud movement. That cloud movement and weather data which are affecting the energy, either wind energy, either solar energy. So Autoencoder. Autoencoder means various method we are using. The autoencoder is one method. We are just creating architecture like an encoder and replacing the architecture like a decoder. So autoencoder used for dimension reduction. Dimension reduction. So autoencoder used for dimension reduction, feature reductions, and they can extract the essential features from the large data set, and we can improve the efficiency by using of the autoencoder. And other deep learning model also will work. So like LSTM will be there, long short term memory, or like various V60, V19, ResNet 50. These are the well-known popular models people are using, specific for classification or redactions or identify the particular area or pattern. So time series forecasting model for solar and wind power. So this is the time series data. That means purely random, no recognition in pattern. But see, this is the curvilinear trends. Quadratic will be there or exponential will be there. Or this is the linear will be there. Linear trends will be there. This is the seasonal pattern. Time, with respect to time, it was like that. Seasonal pattern. This is the seasonal pattern plus linearly growth. So with respect to time, what is the nature of data is going to change. What is the nature of data is going to change. That is the main important factor for time series data. Time series data refer to the data points collected or recorded at specific time interval. Like morning 5 o'clock, that what is the energy consumption was there at Warangal. Morning 5 o'clock or 4 o'clock or 3 o'clock night, midnight 2 o'clock. It was very less. People were sleeping. So almost all power devices was off. So power consumption was very minimum. But afternoon 12 o'clock, afternoon 2 o'clock, more power consumption would be there. 12 o'clock, 2 o'clock, 3 o'clock, this is the main peak time where we are, our people are making foods or doing washing clothes and many things. So till 4 o'clock, again reduction will take place. So 4 to 7, again reduction will be there. Now 7 to 9 o'clock, that means more energy will be utilized. More power consumption would be there. So like example of, you are going to the road and on the road traffic lights are there. So what is the pattern of traffic light? Morning 4 to 6, very less. 6 to 8, moderate. 8 to 12, maximum. Then 12 to 2 and 3, also moderate. Then 3 to 6, maximum. Then 6 to 8, again moderate. And 8 to morning 4 is a minimum. So it's a time interval, consumption is low. That is considered as a data points and with respect to time duration. So it will help for prediction of tomorrow is Saturday. So Saturday and Sunday is the weekend. So in Hyderabad, if we'll go to certain place, like from Begumpet to Secunderabad, traffic is very, very difficult traffic. From morning 8 to evening 8. But if we'll go for Secunderabad to Uppal, different pattern. But Saturday and Sunday will change. The person want to visit railway station, he has to take certain time limit. How much time he will reach there. So if he will write 9 o'clock, he will take only half an hour. But if he will be there at morning 10 o'clock, he will take half an hour, 45 minutes. Half an hour, 10 minutes, 15 minutes. Like the same example in Bangalore also. People are starting morning 7 o'clock, but they are reaching office 9:30. When they are starting their office 9 o'clock, but they are reaching 10. 8 they are starting, 9:59. So morning time they require 2.5 hours. Evening time require 1.5 hours. Pattern is like that. So that pattern is called time series pattern. For that case, what is the use? You can manage your traffic lights controller. That means what is the timing requirement will be there. You have seen many times 60 seconds is there, 45 seconds are there, 1 minute also there, 1.5 minute also will be there. Why it is changing? Automated changing. You are not changing, no one is changing. There no traffic pattern. That's why the machine is able to manage how long people will wait on the signal. So signal wait and signal wait in Warangal 2 signals are there, but if you will go to Bangalore, if you will go to Mumbai, if you will go to Delhi, you herself can realize How much traffic will be there? You believe in Delhi, what is the traffic will be there? Would you believe in New York, what is the traffic condition will be there? So if energy requirement will be there, their energy also required. So all traffic lights are working on solar. You know? So all traffic lights are working, all street lights are working on solar energy. That's why I'm talking about how time prediction is very important. So time predictions, because the sequence of data points collected, recorded by specific time interval, and these data points are indexed in a chronological order, meaning each data point associated with particular time stamp. Data has collected with this time. So temporal is meaning of temporal means time interval. Temporal means time interval. Spatial means only the data point only. There is no time details will be there. So that is the distinguish the time series data from other type of data. So we have time series data. We are going to utilize. So what are the key trends are there in time series? Long term movement or direction of data in a extended period. That trend can be upward, trend can be downward, or even spread. So like a solar energy forecasting. You want to do the solar energy forecasting in a Warangal in the month of April, or in a Warangal in the month of November, or in the month of September, in the month of August, in the month of July. And the same I have to manage same forecasting in a month of January in a Delhi, or in a Mumbai, or in a Chennai. That will be different. Nature of weather is different all three places. So that upward trend might indicate solar energy production due to the installation of new solar panels over time. And also solar panels initially, and after 10 years, after 5 years, the aging impact will be there. So how much energy will be generated? So seasonality definition, regular pattern or cycle that repeat a fixed interval, such as daily, monthly, yearly. So like importance, seasonality is crucial for renewable energy system. As I said, solar and wind energy as a energy production can vary with respect to season, with respect to weather. So like a example, solar energy productions trained to be higher in summer month due to the longer daylight hours. So like example, if you'll see in a month of June, I will talk to timing of the sunset in a city of London in United Kingdom. So morning 4 o'clock sunrise is there, and evening 10:30 sunset is there. And a same case in a month of November, in a month of December, same London city, the timing of sunrise is there 8:30, and the sunset is there 30:30 or 4. Reduced time, sunrise and sunset, the condition will change. And weather also, that is the rainfall is there, or snow will be there. So in that condition, how they will manage solar energy? So they can rely solar energy in the month of, that means May, June, July, August in a city of London. After that, October, November, December, January, they cannot rely. They cannot work. 100% solar energy will not be generated. So like that, these are certain kind of factors are there that will be depend on weather. So that we have to see that. Example, solar energy production will be higher in summer and will be the very lower in winter. Or so wind energy also may exhibit the seasonal pattern with the higher production certain month due to the whatever the wind patterns are there. That means prevailing the wind pattern. That is the key components of time series data. So another factor is train, second factor season, third factor is stationary. So time series consider stationary. If stationary property, that means whatever the statistical calculations are there. What is the statistical calculation? That means time series data will provide mean, variance, or remain constant over time. That means this two value will be constant over time. The stationary very important part because we may forecasting model will be generated. They assume that data is stationary. That means mean and variance is constant. If you compute that value, you may say that this is the data is stationary. So non-stationary data, it lead to inaccurate forecasting. If you are having non-stationary data, that means mean and variance is variable, you cannot predict, you cannot forecast. Your system will fail, your model will fail. So transforming non-stationary data to stationary is a necessary action for reliable forecasting. And if wind energy forecasting, if average wind speed changes over time because of the long term climate shift, then data may need to be transformed to achieve stationary. So like that we'll see 2014, what is the 2033, 2016 487, 540. So it's a previous year capacity and annual conditions will be there. So 591, that is a gigawatts total calculation by the this way, solar by the wind energy. So this is another aspects for understanding of time series data. So we may just compare what is forecasting, what is predictions. So forecasting basically involves the predictions of future data. You want to predict future what will happen. That means tomorrow what will be the weather will be there. Type your Google and just ask what will be temperature of tomorrow. Google will tell you forecasting of 5 days or 1 week. And you can see that tomorrow what will be the temperature, what temperature will be there. So forecasting involves the prediction of future data based on historical data, primarily focus in temporal data. Temporal, I said, time interval data, and identify the pattern or trend over the time. And in predictions, prediction involves modeling, that means between input and output. One is independent, one is dependent. That is done by the machine learning. That is prediction. So exactly predictions is estimate a future unknown value, but it does not necessarily rely on temporal data. It does not worry on time. So in machine learning, we are not worrying about time. Just we are predicting. Apple is an apple, banana is a banana. We have just predicted. We did not consider anyway in the temporal case. Temporal condition means time interval. Data with time, data with time, data with time, data with time. That is future forecast. Prediction and forecasting both are the same aspect for machine learning, but one case spatial data, one case temporal. So here commonly used time series analysis, where historical data observations used to estimate the future value. This is especially relevant for energy system. Especially this forecasting is required for energy system, and such as predicting solar and wind power generation. Forecasting amount of the solar energy will be produced tomorrow based on the past solar radiation data. So in a month of March, first, whatever data will be generated will be helpful for generation of appraisal. It will be helpful for generation of males. That is the main important. The radiation and weather condition will be predicted for forecasting. But in definition of prediction, I said various field like a regression analysis. We discuss machine learning or classification task like a disease classification. Yes and no. Disease classification does not require when you have taken your X-ray, morning, evening, afternoon. Time is not matter. Any time you will give your X-ray. It does not require only prediction is important. One is dependent variable, one is independent variable. So predicting energy output of solar panel based on the factor like panel orientation, tilt, angle, geographic location, that we can predict. That means you have designed a solar panel, you can predict how long it will work. The reliability you can manage. That means 10 years it will work, 5 years it will work, and there is a certain parameter will be there. That is not depend on time. Understand? So in these two aspects, we can work for forecasting versus prediction. So forecasting will do for energy system, and prediction will do for what is the solar panel condition will be there. What is the factor, panel orientation, panel tilt angle, panel geographic location. All these factors will responsible for prediction as well as forecasting. Energy systems are important. So autoregressive model. That means AR model is a type of statistical model that is used for analyzing the forecasting of time series. We are using this model. This model predicting the current value of the time series based data with respect to past value. That means whatever the autoregressive model will be there, indicate that time is a linear combination of past value. Time is very important. This is the case. Phi t x t time. So this is the current value of time. This is the constant value. This is the parameter of the model. This is the past value. We are computing the past value, and this is the error term. We are computing the error. So this is the systems will be there. Energy management strategy, generated power, and then predicting what is the error will be there. So this is the auto-regressive model we are using. So auto-regressive model, generated power and energy management strategies will be there. Just display the strategies, and here forecasting model will help, or data will be generated, how much will be generated. We have to predict. So tomorrow what data will be generated, it is already developed here. That model will tell tomorrow 20 kilowatt is required. After tomorrow 25 kilowatt is required. So that method will be given, then we have to generate the power. So energy need to be increased here. Suppose or decrease will be here. So likewise that generated power will be stored here and will be optimized here. Strategy will be and distributed by grid. Grid will distribute. This procedure will take place. If not having proper generation, we have to provide the strategies here. Display the strategies, based on that this will be utilized. So data will be collected and given to the forecasting, that is on computer. There are multiple methods are there. They are going to provide the forecasting, and generation will take place based on the forecasting model. So auto-regressive model will be there. Moving average model will be there. That moving average model, also time series forecasting, that use past value to predict the future value. So here model indicate that current value linear combination of past value. That means how the data will be generated with respect to this time. So it is a time series data. And there is a mathematically model will be developed. Now auto-regressive combined with the moving average. Both will combine. Both will be able. See that equation. There is the ERMA model. So auto-regressive model and this moving average model, that is analysis for time series forecasting model, that combine the concept of both AR and MA model. And AR-MA model is used to describe the stationary. Stationary means, as I said, constant mean and average. Constant mean and variance. That is the time series data for both dependency between current value and past value. Then dependency between current value and past error term. In the one case error term was there, one case value was there. So you can say AR part, dependency between current value and past error terms, that is MA part, and both has combined. So both advantage has been utilized. One side error will be optimized, one side value will be optimized. Both can be added. So example, forecasting wind speed using this. For that, what we have to do? We have hourly wind speed data from the past 2 months, 720 hours. We want to forecast the wind speed for next 24 hours. What will be the wind speed we need to give? That is a calculation mathematically. And this will write a program. And this program will run. And by that way, multiple times we can utilize this program. Anytime we can utilize this program. So which means we'll consider the past two value, AR. We'll consider the past two error term also, MA, and forecasting. So first thing we have to do, data preparation. So gather the hourly data, speed data for past month, ensure that data must be stationary. Stationary means the constant mean and variance. So it not apply the transformation like differencing to achieve the stationary. Model need to fit. So we have to provide two equations. So with respect to equation, model need to fit model with the historical wind speed data. So whole data will be utilized. Estimate, these are the parameter will be there for AR, for MA part, and then forecasting use this fitted model, which model already fitted to predict the wind speed of upcoming next 24 hours. We have taken old historical data and computed, fitted, and finally forecasted. So tomorrow the data will be required to generate that much. That is the main methodology that we have applied for forecasting. So this is the calculation. This is the calculations. This is the where the value This is the, assume we have following data from last 5 hours. This data has computed. Current or xt is what we want to predict. That means current or what is the value would be there. So by that way, this is the formula, these are the terminology, and this is the data. That means forecasting wind speed. So like, assume we have estimated this parameter. Now this parameter, using this ERMA model, we have computed xt 5.3 plus error. This is we have calculation. So using ERMA model, we found the value and we have forecasting this value. Now another auto-regressive integrated moving average, IMA. Another method has been developed. These all methods we have studied in terms of math. Okay, so mathematically we have studied, but that math will be utilized for analytically and for a prediction or forecasting in terms of time series data analysis. So we can see that model, particularly extension of ERMA model. So this handle the non-stationary. Suppose no stationary data came in picture, what we will do? So we have to handle it. So again we have provided one math that is called additional state differencing. We will make the data stationary. If the data is arrived at non-stationary, we'll make them stationary by using of this math. So ARM model separate the where the number of log observation, degree or number of logs. So this equation has changed. These are the where the parameter will be there. That is the parameter, the parameter of AR part, parameter MA part. D is degree of difference because data is no stationary, convert into stationary by this way. This epsilon is a error term at particular time. Now we have to just to see that. Let's consider example. We have daily solar energy production data. Exhibit a clean upward trend over time. Make it non-stationary. We'll have this model to forecast future solar energy production. So here D equal to 1 indicate that we'll perform cost differential to make data stationary. Now first thing, data preparation. Collect data solar energy data from the past year and perform the differencing, remove the trend and achieve stationary. So whatever the trend was there, remove it, make it data stationary. Model fitting. Model fitting by ERMA model with I has been added. Estimate the parameter phi 1, phi 2 for AR, theta 1, theta 2 from MA and constant T. So like that, forecasting will be, the model will be fitted by these equations and we have to predict the solar energy of for next 1 month. That will be predicted. So formula will be taken care, all method will be taken care. So seasonal decomposition. That means overall seasonal decomposition, one of the important part. So what is the purpose? Seasonal decomposition involve breakdown of a time series data. So data will be breakdown in terms of 3 main components: trend, seasonality and residual. Residual means noise. So noise also one more enemy of data, of signal or any component. So this process help us to understand the underlying pattern and making the more accurate forecast. If we want to improve the more accurate forecast, that means trend long-term progression of time series data, or seasonality is a regular and repeating pattern within the series. And third, residual. Residual means randomly noise will be. So nature of the noise is random. So random noise or irregular fluctuation that cannot attribute to trend or seasonality. Relevance for solar and wind power data. What is the solar data? What is the wind power data will be there? So solar energy production exhibit the seasonality with higher output during summer months and lower output during winter months due to the varying daylight hours. Similarly, wind power energy can show the seasonal pattern based on the prevailing wind conditions. So if it will vary with different season or different climatic conditions. So these are the seasonal decomposition part. So we have see the additive and multiplicative decomposition. So that is the formula TC plus ST plus RT. So in this additive model, time series data YT is a sum of product, trend, season and residual. This model suitable when seasonal variations are there, roughly constant in magnitude. And multiplicative model, that is multiply all three. So in multiplication model, time series data is product of trend, product of season, product of residual. And this model appropriate when season variation change proportionally within the trend only. So within the this condition. Now application of energy data. So additive means it is suitable wind power data where seasonal variation remain stable. Season is stable over the time. But multiplicative means applied for when season variation will be there for energy production, and depending on the level of trade, like increasing the variability with higher overall energy output. That is, these are the two applications are there for energy data. Now practical application. So seasonal decomposition applied for solar power data. So data collection, gather the daily or data with respect to solar energy production for 1 year. We have to decompose. So decomposition will take place with respect to this classification decomposition to break down the data into three different components: train, seasonal, and residual. And we have to interpret train, seasonal, and residual. So what is train component? That will show the overall upward and downward movement in solar energy production. And seasonal component, that is reveals that recurring pattern. Whatever the pattern will be there, like increased production during summer or decrease the pattern during winter, that pattern will be there. That is considered as a seasonal component. And the residual component is a fluctuation. That is the capture random fluctuation or irregularities that cannot be explained either by train or either by season. That we cannot predict by these two components. So we have this is the time. This is the original. This is the original. And this is the stochastic. So we can visualize what is the train will be. So we'll see now how machine learning will work with respect to time series forecasting. So machine learning technique provide the advanced tools basically for analyzing the forecasting time series data, and they can capture the complex non-linear relationship and patch that may miss. So traditionally method, that means we have seen. So relevance, ML is particularly relevant for predicting energy productions from available resources like wind, like solar or any other resources. So accurate forecasting enable the better grid management, resource allocation and decision making. So we may get the decision based on the machine learning. So what are the key technology will be utilized? Machine learning technique used for time series forecasting regular that data. It includes regression model, support vector machines, decision tree classifier, neural network, or combine all models. That is called ensemble. So we have seen various methods. That is linear regression model. That model the relationship between dependent variable and one mode independent. So variable as a linear regression suitable for linearly same time series data will be there. If your data is like that, so you are able to separate them. So we have this is one variable, this is another variable. So one variable, that is this is dependent, this is independent. So like that this variable will be continuous. This output will be continuous. But if this output will be discrete, that means yes and no, that is called classification. So regression, it would be linearly regressions or polynomial regressions or logistic regression. So we have multiple linear regression methods. So this will be suitable for simply if you have linear side data. Non-linear, that means capture the complex relationship between your variables. So you have one variable. So like techniques, polynomial regression. That is the under this category. Example, predicting solar power generation based on historical data, factor like a weather condition, temperature, humidity, cloud cover. Like example, you have taken data from temperature, cloud, and another factor is like humidity. So these are the parameters are responsible to manage forecasting of tomorrow what will be temperature. So you can understand today temperature is 30 degree, humidity is 120 like that. Then you are going to predict. So what, this is the prediction. Likewise, you have collected for morning to evening data, and this data will be utilized for prediction of tomorrow what will be the temperature, what will be the wind power will be there. So likewise, we have the regression model. So prediction of this advantage is very easy to implement, very easy to interpret, and computational efficiency. So limitation may not capture the complex on non-linear pattern. So like that, we'll see the data is varying like that. That is the time series data. We can solve by the regression or SPM. As SPM, I said, if you know the SPM, we are having the condition, data will be there. We'll draw the hyperplane. And we have drawn two more hyperplanes, positive or negative. So we have two kind of data. This is the circle. This is rectangle. So this distance must be maximized. So like that, you will see here, this is the maximum margin. Data, this is support vector. It will touch to this line, support vector. So it's the optimal hyperplane. This is positive hyperplane, this is negative, and we have separated. So it is effective for non-linear data, robust to overfitting, and can handle high dimension space. If you have multiple dimension, what you will do? Multiple line will be drawn. 4 category, 5 category. So multi-class problem also can be solved. So SPM used for a optimal hyperplane, separate the different pattern in time series data. SPM extend to regression task. So whatever regression task we have done, it is extended with respect to regression analysis or classification analysis. And computationally intensive, require careful training of tuning of the hyperparameter. Like random forest and gradient boosting. These also different techniques are there. So random forest is an ensemble of multiple distant data. What do you mean by ensemble? Multiple techniques. So 5 classifier applied in a parallel. So we have multiple decision trees. So this decision will take the perfect output. This decision will take the perfect output. So it's an ensemble of multiple decision tree. Improve the accuracy by averaging of individual tree. Average of first tree, second tree, third tree, complete average. So it reduces the overfitting problem and enhance the robustness. And by using of gradient boost. So this is another technique. This is an iterative technique. It will build the ensemble of weak model. Sometimes one model has given accuracy 60%, one model given 98%. The strong model, weak model. We want to improve the efficiency of weak model. So ensemble of weak model, usually decision tree, focusing on correcting the error made by previous model. So we are going to correct which model has faced earlier model. We have to correct that. For example, random forest and this technique forecast wind and solar power productions into account various influencing factors like weather conditions, geographical location, and historical trend. So if you want to install the wind power at Warangal, not possible. So wind power, there are certain locations are there, they are installed. In India, there are many locations where wind power generation plants are there. But everywhere you cannot install. You have to identify, like if you are finding the water, you want to do the groundwater. So you have to check whether water will come or not, at what speed water will be there. Everywhere you cannot find the water. Okay, everywhere you cannot create the bore well and other things. It's not possible. So likewise, solar energy, certain factors are there. Wind energy, certain factors are there. Certain locations are there. Geographical location is one of the important factors. So like that, high accuracy, handle complex interaction, robust to overfitting, limitation, computationally intense. You want more computational calculation. Require careful tuning of hyperparameter and very less interpretation with respect to simple. So this is the actual power versus predicted power. by generated by this model. Actually, what generated, what is the predicted one? You can see by it. So this is actual. This is predicted. So 20% lag. So actual was 90 kilowatts of load. Generated 70. So we can modify. Now comparison. So we have work on performance parameters. We all of know. We have discussed in the first session precision, recall, mean average error, mean absolute error, root mean square error, R square error. These are the calculations, and we have to optimize these parameters. Once you optimize, so you are a researcher. If you are writing a paper on wide energy, solar energy data, you have to develop the model. So what you will do? First, you will collect the data. Data already are readily available. You have to clean the data by pre-processing. You have to identify the features, feature extraction, feature selection, and modeling of the classifier. You can use any model. Then, if model has trained, then you will find out the classification report. Classification report will tell you what are the performance measures you have calculated. So that is the more important part. So once model, even this error less, that means your model has reached correct output. If mean absolute error is very just high, that means you cannot work for that model. You have to change the model or you have to tune the hyperparameter. So measure the average magnitude of error between predicted and actual value. Provide the measure of average magnitude error giving higher weight of larger error, or R square error. It tells the proportion of variance in dependent variable that is predicted from the independent. And precision, accessing how well the model is capturing the variability of data. Accuracy, evaluating the precision of different models, predicting energy productions for wind and solar sources. Computational efficiency, we are comparing the computational resources that is required by different models to process the large data set, and particularly for generating the forecast. So introducing of deep learning. Now we have added deep learning, convolution layer, pooling layer, convolution layer, pooling layer, convolution layer, pooling layer. Finally flatten the data. That means fully connected neural network. All node will be single node. This fully connected node multi-layer perceptron will be utilized for classification. These are the model. Here we'll apply the activation function related to software or sigmoid. They are responsible to compute the probability. So probability of this will be high, classified. Probability of this will be less, not classified. Like that, multi-class problem that can be solved. So here time series data given to convolution layer, multiple layers are there, multiple filters are responsible to extract the feature. This approach is called feature learning. Like tomorrow new data came in picture, so no need to change the model. Just fix it this bridge, change this one. Day after tomorrow new data came in picture. Don't change model. Data same, low level, medium level will be same. Nature of the feature will be same. Feature learning means last layer need to be modified. Train it. So you need not require to train entire model. That is called transfer learning. Transfer the weight from yesterday model to now, today also. That weight can be transferred. Like you have learned apple from childhood, you still did not forget. You know, till your last age, you will be remember apple as an apple. Any kind of thing you can forget, not possible. That is not there in memory. That you have already learned. So whatever the feature has learned by the model, it will not go. That weight already saved. So you can retrieve that weight for the new model. That is transfer learning we are using in deep learning. Transfer learning means you need not require to train entire like learning. Just only 20 layers are there, 18 layers just trained, already inherit, and last 2 layers going to train. So trainable parameter will be very less. Non-trainable parameter will be very high. So that is the way will be there. So how we can introduce the deep learning? Deep learning is a subset of machine learning, has significant advancement in field of time series forecasting using traditional methods. So here deep learning model can automatically learn complex patterns and relations data without manual feature learning, without handcrafted feature learning. Just every time feature extraction will be the under the feature. benefit of feature learning, automated feature learning, and handling non-linear relationship. These are the benefits of deep learning. And capturing long-term dependency and scalability and robustness to the noise. So the model will become more robust. It can sustain the attacks. It can sustain the noise. All these are the main benefits of the deep learning. So like LHTM1 architecture will be there. It's a recurrent neural network. We are using that. In that model, memory cell is there, input and forget gates and output gates will be there, predicting the solar and wind power generation. So we want to predict how we are doing outcome, accurate forecasting of production, aiding the grid management and resourceability. Data historical solar radiation, weather data collected, and model LSTM for predicting of future solar energy production. So this is the architecture available, we can use it. With respect to memory cell, store the information over a long period. That memory part will be added here. And input, control the new information for entering into the memory. And forget gate, decide the information to discard, which need to be discarded. Output gate, that will be determine the output based on the memory cell and so CNN also part of convolution neural network. The application to solve the problem of time series data, merit. And, forecasting of wind energy or solar energy, take the data, create the model, provide the outcome. Improve the accuracy with forecasting, enable the better operating. So comparison with LSTM and this strength, capture the long-term dependency, sequential pattern in data, use cases suitable for time series data with long-term dependency. CNN, excellent for feature extraction. So CNN is very important for feature extraction and handling spatial hierarchies. And use cases, effective for time series data with spatial dependency and patterns. Choosing the right model, LSTM best for where past information over a long period is very crucial. And CNN, when data is local pattern or spatial hierarchies are there, at that time you can use it. Okay. So I'll stop here, then continue the other part after 5 minutes break. सब लोग काम कर रहे हैं. bridges are there, especially for smart grid and energy system. So according to the application point of view that we have seen, so as we have seen smart grid, the smart grid, these are the all energy resources and how we are going to generate the power and how power will be transmitted to the specific places. So it will prevent the cyber attacks like hacking or malware, and we have to ensure that reliable and stable power, particularly supply point of view, and also we have to prevent the consumer and operational data. So particularly cyber case help comply with the regular standards and strengthening the national security and build the trust. So cyber security is one of the factor in smart grids because the implementation of technology, what we have seen so far, that process and practical design to protect the smart grid infrastructure. That is how we can help to smart grid infrastructure, how we can protect them, especially from cyber threats are there, unauthorized accesses are there, and malicious attacks are there. So it involves securing data transmission or securing communication, and whatever the control system is available, you have to secure that, and especially for energy management process against the cyber attack, cyber risk. So why cyber security matter in energy system? So as of now we have seen cyber grids are vulnerable with respect to cyber attack. So interconnected systems increase the attack surfaces. Then when we are increasing number of networks and particularly in the interconnected system, so threat actors target the critical infrastructure. That means threats are particularly targeting to infrastructure. So related to that, various consequences will happen. That means are related to cyber attack for energy system. So power outage will decrease, or sometimes blackouts will occur, or we can say financial losses because people are using financial and economic disruption will take place, and it will be harmful, or the loss of particularly consumer data. The data must be secure, or particularly various privacy breaches also will be there. So threats are especially, our national security is one of the important factor in cyber. So this is the all reasons why we are moving towards the cyber security matters, especially for energy system. So we can say how evaluation of smart grids will be there. So we have seen previously traditional grids were there before the smart grids. So centralized power generation, manual monitoring was there during that time, and data exchange was very limited. But when we reach smart or modern smart grids because of digitization, so decentralized energy production, especially for renewable energy resources like solar power or wind power, and real-time data collection. So continuous data will be collected in real-time manner, and system will become automated, as well as bi-directional communication. We can see here that the system smart grids, how the thermal power plant, solar power, how the wind power, how the nuclear power, and we are utilizing the power especially for electric vehicles, especially for smart homes, especially for cities or smart cities or industrial plants. So related to that, IoT and AI integration has improved the efficiency of the system. That is the main important aspect here. So we can see the key components, especially for smart grids. So we have seen all meters, all energy meters became smart meters in the current condition. So measure the communication energy consumption. Secondly, SCADA system, supervisory control data accuracy system. As I said in my first session, PLC and SCADA, it was the older technology in industry they were using. Now we are going to replace by AI. All this technology will be replaced. So SCADA will monitor and control the power grid operation. That means power will be generated, power will be transmitted, and will be supplied to the user based on the demand. And we are forecasting also, as I have told in the previous session, how we are going to forecast the power generation with with related to time series data. So IoT devices and sensors will be the part of system, because we are going to collect the data from the sensors and transmit the data through the IoT devices. Communication network is another factor. We have to facilitate the data transfer. So here security part is very important. Energy storage system, where data will be stored, where energy data will be stored based on the balancing between supply and demand. And finally distribution. So distribution of renewable energy integration, that it came in picture. So distributed energy resources. And here cyber attacks on smart grids. So cyber threats and in smart grids, various type of cyber threats are there, like malwares are there, or DOS attacks are there. Many in the middle attacks are there. Insider threats are there, and data breaches. And so, why smart grids are target? What is the reason? Critical infrastructure dependency, that is the main important part. High financial and security tax are there, and that is the legacy system with outdated security, because we are using the older technology security, we can see. And this is the types of cyber attacks will be the DOS or network intrusions, DGS, or various other attacks also that would be there. So recently cyber attacks on energy system, like a Ukraine power grid attack 2015 and 16. It is the history. Or hackers disrupted the electricity supply, leaving 230,000 people without power. As well as colonial pipeline Rizomare attack in 2021. That is the cyber criminals shut down the fuel distribution in US. Also one more, India's Mumbai blackout 2020, that suspected cyber attack caused a city-wide power outage. So these are the main area we have seen. So cyber security challenges is very important cyber grid, because complexity and interconnectivity issues, because cyber security integrates the various technology, especially for cutting and vast attack surfaces, and interconnectivity is very important between the devices, that increases the vulnerability to cyber threats. And legacy systems often lack modern security features, as well as that is a more entry point for attackers because of IoT and cloud integration. As we are integrating IoT and cloud, that is also one more factor because of the interconnective issue and complexity. Smart meter security issue. Smart meters, as we have seen, became very popular from the past 10 years. So smart meters collecting the and transmit the real-time energy data. Data tampering may possible. Unauthorized remote control also for electrical supply. Privacy breaches because of the consumer data. So solution, data encryption technology needs to be adopted, or secure firmware will be provided, or regular audits must be there. These are the requirements for a smart meter security system. If we talk about communication network, is very important, because threats are but particular in terms of data interceptions via man in the middle attack. This is the one kind of attack will be there. And jamming attack. Jamming attack, disrupting the wireless communication. So various jammer has been developed, various frequency will be generated by various devices. It will jam the signal. So like spoofing attack, injecting the false data into the grid. They may inject the false data into the grid. So mitigation will be done by the encryption communication channels. We have to encrypt the all communication channels, provide the proper security mechanism, as well authentication. That means authentication, and we should give the access control mechanism to specialized people and specific people based on the various security factors. So this is the another attacks will be there. That is the SCADA system risk. SCADA, because supervisory control data system, it's a particularly manage the grid operation, how grid power will be generated, how will be distributed. All this run on outdated operating system, old operating system, and expose the cyber attack due to the remote access features, and also having the potential for large scale disruption if it is compromised. So preventive measures are segment the SCADA networks, as well as multi-factors authentication techniques need to be utilized, and regular patching and updates will be very important, and it must be included. So like a regularity and compliance challenges. So various challenges are there. We have seen various regulation is very important. So related to ISO, related to HPAA, related to IT Act, related to PCI DSS Act, related to Copyright Act or IPR Act, NST Act, means protocol requirement. So American country has given NERC, CIP, protect the critical infrastructure. NIST cyber security framework, risk management guidelines they provided. ISO and IEC 27001, information security management. And GDPR EU protects the consumer data privacy. With respect to this protocol, that is the rights they have given the standard to protect the consumer data. They cannot share the consumer data with any people or any kind of group of. So like a challenges in compliance because of cost is one factor, costly implementation, lack of skilled workforce, skilled manpower, as well as constantly involving the cyber threats, and they are continuously moving in various hackers and technologies as adopted by many countries. That is the important part to discover and provide the special solution for that. So cyber security solutions for a defense mechanism. So risk assessment and threat detection is one of the important parts. That means identify the vulnerability before exploration. So regular penetration testing is required, security information and event management system, and AI power. That means you have to involve the AI for intelligent, threat intelligence, particularly for early detection. That is the assessment part will be there. Network security measures. So firewalls and intrusion detection system IIDS has been implemented. Various filters has been implemented and monitor the incoming traffic for anomalies. So anomaly detection will take place, and encryption techniques. So various end-to-end encryption technology will be provided for secure data transfer, as well as segmentation of network. So network will be segmented, isolated, particularly for critical grid components from the public internet. So these are the certain network security measures are there. Similarly, zero trust architecture that has involved in a smart grid. So that concept means it's a never trust or always verify. No, never trust and always verify, that concept will be there. Principle, continuously the monitoring will take place for all devices as well as all users. That is the main important factor in this case. And another factor, that is the least privilege, particularly access for critical system. If any critical system will be there, privilege access, least privilege access will be given, and strong authentication. That is the main important part for biometric methods like people are using. So biometric methods are improving, like a face recognition matrix or methods, or like a fingerprint methods, or double security methods. So like zero trust architecture, you can visualize these are the access requests, users or different devices. This is the verify every access attempt, and this is the determine access eligibility, yes, no, or like that. And these are the data assets, application and services, assets, data and application. So by that way, we can just provide the architecture, especially for smart grids, AI and machine learning for cyber security. As of now, we are employing the AI in every application point of view. So by that way, we can detect the pattern. So AI will help to detect the pattern of cyber threats, cyber attacks in real time manner, as well as automated response of detected attacks. That is the main important part. And third, reduce the false positives in threat detection. So these are the use cases. Predicting the vulnerabilities, identify the anomalies in a energy consumption pattern. So we can say this is EML benefit for cyber security system. That is process the lots of data quickly, recognize the pattern in data, automated routine and effective tasks, and provide the advanced analytics, and particularly this predictions, and continuously provide the system efficiency, improve the efficiency of the system. That is the very important. So we have involved multiple technology like a blockchain technology for secure transaction. So we can see here how blockchain helps or ensure that data integrity for energy transactions. So we can say this is the future of secure transaction. So decentralized, whatever the they are having the prevent the unauthorized data modification. So unauthorized people cannot modify the data, will be done by the blockchain technology, and smart contract will be given. That is automated, secure, peer-to-peer energy trading will be there. So this is the important part. Now multi-factor authentication with respect to MFA and IMA. So this is the identify access management and multi-factor authentication. So we can say example for multi-factor, what you know, username and password. Now something you are on by the phone. By the phone you have to give the approval, and then something you are fingerprint sometime. So you are increasing the security. That is the main important part. So ensure that only authorized personnel access the infrastructure. We are going to ensure like you are using mobile your Gmail ID to other place. So what is happening? They are asking through your phone. So you are authorizing first, then you are accessing your Gmail. So likewise, you have to first ensure that authorized access and multi-factor authentication, that combined passwords are there, or biometrics technology will be utilized, or smart tokens. All these are utilized for particularly access control. That is the main mechanism given for multi-factor authentication and incident response and recovery strategies. You can see here finger this preparation, detection analysis, contaminate and other case of recovery, then post-incident activity. So in this case, what are the key component will be there for response plan? Detection. First, identify the attack in real-time manner. Containment means isolate affected system for prevent the spread or recovery. So we can restore the normal operation using backup data will be there. Or post-incident analysis, we are going to learn from the attack. So we have learned the pattern of attack and we are providing more security. We are going to increase the security level. So security mechanism will change. So cyber security training and awareness is very important part. Nowadays you are listening the through mobile phone, the one voice recorder is coming. There are many cyber attacks happen from the past 6 months with people. So what happened? Government have started one IVRS system. Before call, you are listening one message. They are saying no one is calling. Like people are saying, I am from CBI, I am from this, I am from this, or your person is there in hospital, you pay the amount, or in UPI, you just click the button. Like that, many cyber fraud happen. So governments are now started to provide this. So awareness is very important. So that is training. Human error account for 90% of cyber incident. Because of human only, we are going to just suffer from this cyber incident. So effective training strategies. Regularly security awareness is important. Workshops given, simulated phishing attacks exercise also, and developing a culture for cyber security awareness. That is also very important part. So future, like we have to provide the proofing for smart grids against cyber threats. So long-term strategies. So continuously security updates. Advanced machine learning and AI technologies required for threat intelligence, or increase the government and private sector collaboration. That is very important. So if you see the particularly in future trends, in the future you can say quantum computing, post quantum cryptography. So that will be the future. So how quantum threats with respect to future quantum computers could break the traditional encryption techniques. Post quantum crypto solution, quantum safe encryption algorithm that need to be designed. That is the future will be there. Now see the decentralized energy system and security implications. So we can see new security risk with decentralized grids. So more attacks due to the multiple energy resources are there. Higher complexity in managing distributed systems. So solution is we have to provide the secure peer-to-peer energy transaction using blockchain technology, or strong authentication for distributed grid operations are there. Like government policies, global collaboration. Role of governments is very important for establishing the cyber security regulations for energy cyber security, encourage the research in that domain. Global collaboration, because sharing the threat intelligence across the nation and creating the unified security frameworks. So AI based encryption, detection and security enhancement techniques. There are many research are going on by AI security. AI refer to system that simulate human intelligence, how human is identifying, analyzing or predicting the based on the cyber threats. So role of AI in cyber security, AI automate the threat detections, AI provide the response and mitigation. It enhance the real time security by identify the anomalies faster than traditional methods. That is why AI is essential for security. enhance the threat detection analysis, vulnerability management and patch prioritization, phishing and email scan detection very easily, malware detection prevention, user behavior analytics, enhance the security risk management, automated incident response. All this can be aided when we see the AI will be involved in cyber security. So intrusion detection with AI integration. We will see that monitor the networks for a suspicious activity and network-based system. These are the types are there. Host-based ID. So AI-driven machine intelligence, machine learning, deep learning will be utilized to detect the anomalies in real-time data, understanding the risk, or shaping the security strategy, regularize the compliance and faster response time. So how this benefits will be given for this intrusion detection with AI. How AI will improve the cyber security in smart grid. So we can see the automation. Automation will provide the threat detection without human intervention and identify the abnormal pattern in grid operations, predict the particularly and mitigate the cyber attacks before this happens. And finally, improve the decision-making capability using machine learning and deep learning with real-time security management. So AI-based intrusion detection techniques. So what is intrusion? That means we can say process to monitor the network system activity to malicious attacks on policy violation. So signature based IDs we are using, anomaly based ID we are using. So this is the networks, this is the host, and this is the anomaly based detection. So signature based detection. So recognize the known attack pattern, detect the deviation from the normal behavior. This is the traditional versus AI. Feature, traditional and AI. Behavior based, faster, continuous learn, more precise. So AI improve the by reducing the reliance on predefined rules, detecting the new attacks vectors dynamically. This is the very important factor. Then machine learning, so supervised learning, unsupervised learning, or reinforcement learning. Many techniques has been developed. Deep learning, neural networks, convolution neural network, or recurrent. So analyze the sequential network traffic, detect the malware signatures, identify the complex attack patterns. So anomaly detection using AI. That means these are the local outlier factor. This is the support vector machine, autoencoder, Bayesian network, k-nearest neighbor. So AI flags abnormal data traffic in smart grid before attack occurs. So identify the deviation from expected behavior and useful for detecting the zero day. So there are certain challenges are there like AI based idea system, data quality, because AI relies on high quality data and false positive is going to increase. So we have to provide the adversarial attacks like attackers attempt to detect descent AI model. So these are the false alarm rate or low detection rate, unbalanced data set or response time. These are the challenges factors are there that can be resolved with respect to various AI and machine learning based. So this was the part of cyber security, how we can help. Last part will be how future trends and research direction in terms of energy system. Last part, what are the future research directions are there, especially when we are doing the research. So as of now, we have discussed forecasting, time series data analysis, and various renewable energy resources, and how we can deploy the cyber security mechanism, especially for smart grid and for sustainable energy system. So according to future trends and research direction, that whatever the emerging technology, as I said, every technology now going to be involved with AI driven. that means the technology and trends, how we can manage the information which will be collected from the various sources in terms of sensors and devices, and how we'll make our system, especially for electrical energy system, how we can involve the AI, and particularly the finally it will be helpful for in future. And that will be the main part of sustainable technology. So renewable energy system, as of now we have seen like natural resources, like example of sunlight or wind, water or geothermal heat to generate the power sustainable. So renewable energy particularly offer cleaner and more sustainable alternatives. That means it reduces the carbon emission. That is our main factor of all countries are working. We have discussed in the first session how different countries they have provided innovative ideas or related to encouragement for applying of sustainable technology, especially with respect to AI, and for reduction of carbon emission and promoting the energy security. So transition as will be there from renewable energy is very essential for reducing the greenhouse emission and mitigating the especially for climate changes and achieving the sustainable development. That is the main goal of our program, as we have given how sustainable technology involved with the help of AI. So global initiative, as we have seen in Paris Agreement, promote the clean energy. They adopted to the advancement solar, wind, hydro, smart grid technology. And this decade is very crucial for transforming, especially for energy sector, by adopting the green energy, and improving the efficiency by two factors: automation and artificial intelligence. And there are strong policies are applied by various government agencies, various policies developed by government. So that is needed to manage the complex changes on a single platform. That is the very important part. So according to our requirement, that means we'll see how AI will be involved, especially for energy policies for sustainable future. So global warming and sustainable development are one of the essential component for modern age and require the multidisciplinary measures. And sustainable energy has impact both regional and global level. That having the both impact, and we have to measure the energy poverty and sustainability. So we need to specific matrix. We have to provide indicators. We have to develop tools, techniques that can adapt the changes, especially for supply and demand. As we have seen, we are working for energy generation. So as of now, we are using mobile phone. We are using various technology. So if you are increasing a technology, like you are transforming from 5G to 6G, 6G to 7G, or your devices are also increasing day by day, your mobile memory are increasing day by day. So based on the memory, your power consumption requirement also increasing. Your power requirement also increasing. That means your demand is increasing. So based on the demand, we have to generate supply. So supply will be very important, but demand is more also important, because user are expecting in all devices will work when we'll have the sufficient energy with us. But we have to generate the energy. We have to provide the specific power, that means energy factors. So here AI will play very key role in modern energy policies, helping to improve the sustainability and fight the climate change. So energy policies include the rules and guidelines to control the how energy is produced, how energy is transmitted and shared and used, with limited flexibility of decision making. This is the one of the important factors. So energy policies focus on, there are key issues are there. What is the key issues we learned so far? Security, that is the last. Sustainability or affordability, you are able to afford, or accessibility. So these are the factor is there. So energy policies, whatever the energy policies we have seen, so according to that, establish the goals, distribute the resources and regulate the energy use. So it promote the efficiency, support the renewable energy, overseas companies and fund research. So we have to provide the more fund to the research than we are able to do. So to prevent the failure of energy policies, it is very crucial to promote fairness, equality, and particularly various factors are there like equity or inclusiveness in energy policy development project decision making. So timely and effective measures are very important for preventing the policy failures. So we are going to integrate the machine learning and into energy policy, analyzing the efficiency factors, global management practices. AI will play a very important role for policy development. AI ML will help make decision becoming more important in the energy sectors or in terms of energy or power system. So various challenges and opportunities presented by integrating the AI into energy sector. So far there is no clarity how we are able to develop or create and apply the policies for ensuring the fairness or equality or including the decision making. So therefore the goal is to create the clear guidelines that to combine the policy, combine the data science, combine the AI in engineering, and combine the management, business and social methods to support the transition, clean energy and reduce the carbon emissions. So our final factor for sustainable development is clean energy and maintain the reduction of carbon emissions. And also it will be affordable to the user and society. So global energy landscape will see the 5,500 gigawatts for new capacity by 2030. So renewable on the rise, global renewable energy capacity skyrocket by the 5,500 by 2030, driven by the government policies, the technology and advancement, growing the environmental concerns. So this growth will require significant investment in research, in development, unlock the full potential of renewable energy resources. So what are the shifts toward the renewable energy central to decarbonization, that efforts and achieving the global climate goals? So continuous investment in research that we are getting many funding. As Professor Mohan sir has explained how many projects he did with the support of many European countries. That agenda was that provide the research, provide the to improve the development, especially for address the challenges of grid integration and storage for renewable energy resources. So these factors are there like real-time monitoring, predictive analytics and grid integration. Already we discussed about that. We are going to provide the real-time monitoring. So various AI algorithms are responsible to monitor the data in terms of energy flow, in terms of predictive demand, in terms of fluctuation, optimization or distribution of efficient grid operation. Also predictive analytics, predictive maintenance given. The AI will helpful for downtime, reduce the downtime, optimize the performance of renewable energy installations, grid integration. So we are going to apply the AI grid. So AI power system that can facilitate the integration of diverse renewable energy resources, including solar, wind, and hydropower. So according to that, we are going to see the geopolitical dynamics in China's dominance in renewable energy fund. So China has emerged as a global leader in the renewable energy, driving significant expansion with respect to solar, wind, and hydropower. So technology transfer. China actively promoting the technology transfer, international cooperation in energy, and aiming to influence the global energy landscape. Strategy implications. China dominates in renewable energy, present both opportunities and challenges, especially for country in terms of technology access and market competitions. So there are certain energies intersections for AI and sustainable energy technology. So energy efficiency is one of the important factor, smart grids another important factor, and renewable energy storage another factor. That means you have to deploy the AI for energy efficiency, for energy smart grids, and we have to integrate the AI into the power grids, and also it will work for real-time monitoring and control and provide the enhancing the reliability, stability, and particularly for improving the renewable energy resources. So AI algorithms will help optimize the energy resource storage solution, ensuring the continuous supply of renewable energy. So according to that, nuclear power also is very specific part for the enhance and tripping output and future potential. So advanced reactors developed, like next generation nuclear reactors are being developed with enhanced safety features and carbon-free energy and increase the output. So nuclear power experience resurgence with global output expected to triple in the coming decades. Another case we can see here, AI driven energy demand, data centers and clean energy infrastructure. That means growing with respect to demand, with respect to renewable energy solution and energy efficient. Policy frontiers, especially for financial and technological solution for global sustainability. So here in this transition, a sustainable energy future requires multi-faceted approach, combination of policy support, financial investment and technological advancement. These are the future trends are there. So energy transitions at the decarbonization scenario at the glance. So according to study, is electricity and hydrogen share of the final energy consumption is estimated to reach 32% by the 2035, 50% by 2050. And electrification is the key in boosting the energy efficiency in building the and transport and industry. Electricity will use expected rise with respect to 20%, 40% by 2050. So renewable will become the standard, accounting by 50% of the power mix by 2030, 85% by 2050. The step for energy policy development, that means we can see here, these are the steps are there, ranking phase, consensus phase, formulation phase, conceptualization phase, assessment phase or acceptance phase. So these are the certain phases are there. So step for policy development, these are the phases we have seen. This is the landscape for decision making building block for energy policy making. These are the energy policy scenarios are there that will focus on low carbon energy, prioritize the data management, emphasize the environmental sustainability, explore the governance and decision making, and ensure the reliance and access to resources services. That is the, so how will AI will shape the future energy policies? So we have to apply the data driven methods, that is the operation and reliability can be improved, and solving the data driven machine learning model for iterative process to organize hierarchically and stage develop the model to support energy policies and outline future. So AI driven policy development building blocks are there, and this case data collections, energy policy development, AI and machine learning implementation and monitoring and evaluation with respect to automation or with respect to other factors. So here this is the crucial component for an emerging approach for AI in terms of energy system, data platform infrastructure, AI algorithms, policy and regulatory framework, stakeholder engagement and communication and dissemination. So related to that, these are the AI machine learning methods for deployed for integration like classification, regression, time series forecasting, association analysis, clustering, anomaly detection, feature selection, ensemble methods, deep and transfer learning. All these kind of methods we have discussed: text mining, computer vision, natural language generation, dimension reduction techniques, reinforcement learning, generation methods, and network and graph methods. So there is a research gap in future direction, integration of AI in policy process, development of metrics and indicators, benchmarking AI applications, and particularly addressing the socio-economic impacts and exploration of energy system model, and especially for policy documentation processes. So various research opportunities are there. Advanced renewable energy technology, we have to work on that direction. Energy storage and battery technology, or smart grid and AI integrations, energy policies and market optimization. So AI-driven policies for energy pricing and trading, policy framework for integrating renewable into existing grids, strategies and carbon footprint reductions and net zero, and decentralized and microgrid system. So AI-based optimization technique will be utilized for especially for microgrid distribution and hybrid renewable microgrids for remote and rural electrification. So rural area electricity is very important. Electrification and sustainable mobility. So AI driven optimization for electric vehicle charging, especially is wireless charging, vehicle to grid integration, hydrogen fuel cells and alternative sustainable transport solutions. So these are the certain research are available opportunities. Waste to energy and circular economy approaches are there, and energy efficiency AI based optimization, especially for AI based smart metering and energy consumption analytics, predictive maintenance for power system using machine learning, and optimization of industrial energy use and smart building. These are the research areas. People are doing research as per the availability of literature, hybrid energy systems and grid resilience. So AI assisted integration for hybrid and renewable energy resources and advancement in fault detection and self-healing power. Already we discussed in the first class how self-healing power, self-fault diagnosis will take place with the AI and sustainable matrix and life cycle assessment. So AI-driven environmental impact assessment, development of sustainability performance indicators, policy-driven approaches, especially for long-term energy sustainability. So these are the factors which we have motivated us to work in terms of sustainability for clean energy as well as particularly to reduce the carbon emission and maintain the global warming and other factors. So this is the analysis we have seen. These are the research opportunities are there. So that's all from my side, and so I have completed my part. Thank you, one. Any query, any participants from any participant side, any query, any question? So I'm expert from artificial intelligence. Okay, so related to whatever the part I have discovered, this is the particularly my own interest in towards the sustainable development side, because from the past 2 years I am taking one of the mandatory course in the department, that is outside of students, related to sustainable development. And in that case, we are not looking sustainable development only for energy. We can find out sustainable development for every area, like healthcare or like in different domains. Okay, so sustainable development, how we are going to realize, as we have seen various case studies are there, how we can deploy the artificial intelligence and machine learning and deep learning. Okay, so this is the future research direction. Okay, towards this topic. So any questions from any participants? Any questions? Any queries? So if you are a computer science person, cyber security will be your part. You are an electrical engineer, you can do the renewable energy part, you can do the electric vehicle part, you can do the power system part. If you are electronics engineer, you have healthcare part, you have optimization, or as of now today, forecasting. Okay, forecasting of time series data. So that is the common for everyone. Okay, data will be collected, recorded with respect to time interval. So you can deploy the algorithm related to that. So as I said, there are 10 problem I have shared. Okay, I will share this PPT also. All material will be shared. Please go through and read, because the time is very limited and we have to cover multiple parts. That's why we could not cover entire methodology point of view. Okay. So thank you. If you have no questions, we can close the session. Thank you, Vanan. Yeah, we have 3 times. Sir will join and he will take the 2 more hours. Okay. Thank you.
So good. Shall we start now? So good morning to everybody, and I hope that you have a wonderful session before the tea break. Continuing my lecture from yesterday, today I would like to focus more on how this future distributed electricity network based on microgrid should operate. So in this today's lecture, I will try to conclude what we have learned previously. Previously, we studied that we need to have renewable energy system with more and more integration of renewable energy sources. In the first lecture, we tried to understand at very high level how the off-grid energy system should be designed, taking into account the available energy resources at that particular location, taking into account the available load profile information of that particular location, and then based on the load prediction, based on the energy resources prediction at that particular location, based on the historical data, how they can help us in finding out the optimum techno-economic sizing of system components which can help us to fulfill sustainable energy demand of that particular location. And for that, we also discussed briefly how this operational characteristics as well as the availability of energy resources which we need based on the prediction for doing the analysis, for finding out the optimum sizing of system components by considering replacement of the system components over the lifetime of the system. And then we discussed that how we have to calculate net present value, and based on that how we can calculate levelized energy cost and find out the solution which should be more economical as well as in a position to fulfill the technical characteristics. And also then we discussed that how such type of off-grid is going to be connected with the main grid in the future, and then how we have to design or how we have to develop different operational characteristics of that microgrid when it is going to connect with the main grid in the future. So we will continue that. And then also briefly we discussed about sustainable energy conversion using hydrogen as an energy carrier also. Okay, and in that also we tried to understand how this machine learning techniques can help us in doing the prediction of hydrogen production based on the renewable energy sources, and then how that green hydrogen production can contribute towards the different application of hydrogen, including automobile, process industries, and so on and so forth. Then also in the last or in yesterday's lecture, we discussed about one European Union Framework 7 project in which we tried to understand how the scalable energy management infrastructure for aggregation of households can be there, and how we can utilize centralized approach, that is the virtual power plant approach for managing the demand of group of houses through aggregation based and shifting the operation of non-critical power intensive load, and for that how we have to include ICT infrastructure that we studied in the last lecture. So all these things which we are discussing now, right? So considering the key focus of our course on sustainable technology development, then now I am going to take it forward to see how we have to redesign or how we have to change the configuration of future electricity network when such type of off-grid system are going to be connected with the main grid. So they are going to be operating as a microgrid but with interface to the main grid. So there are lot of things with proven technical solutions which can be deployed rapidly and cost effectively and which can enable the existing grids. Now it is a very important point to enable the existing grid to accept power injection from all energy sources. Okay. So this point, what it has been said here, it is a very important point here. It means that when we are talking about different energy sources and especially when we are talking about the distributed electricity network, it is going to be a big challenge. We need to provide a technical solution which can help us to operate that particular distributed electricity network, maybe as a microgrid. Okay, it means the concept or the methodology which we discussed in of the off-grid system, how that has to be modified when we are connecting it within the electricity network, that we will study. So when we want to connect, it is not only the technical parameters which we need to take into account, but at the same time we have to consider about regulation and commercial framework for facilitating trading, means to ensure that all we will in a position to accommodate with wide range of operating situation. It means that this is again a very important point when we are operating this different type of energy sources within distributed electricity network as a microgrid. So what type of regulation and commercial framework should be there? Because within the microgrid also we are going to have lot of distributed energy resources, energy storage also. So they also want to make the profit. So for that profit, right, what type of trading mechanism should be there which can help us to have more and more renewable energy sources within the distributed network, that we will study. At this moment, most of the platforms, they are available, but they are not having that much capability to do the planning and development of network, taking into account the stochastic nature of distributed generation, both in steady state and under dynamic condition. So here under the dynamic condition, you can see that if we have load dynamics, and with reference to the load dynamics, if we are going to have the intermittent renewables also, so how we have to develop some analytical tools which can help us in understanding the intermittency of renewable energy sources with reference to the load dynamics also. And then here our objective is to operate it as a grid connected microgrid. So whether we will be requiring any dispatchable power source within that distributed network, right, to overcome this dynamic condition and to operate this microgrid more as a self-sustainable unit. So you got the point now? So here maybe I should explain, I missed to bring the a document camera, but maybe here briefly I will explain you. So when we have this microgrid here, and in this microgrid, when we have all different type of renewable energy sources, energy storage, of course, we are going to be there, load dynamics is going to be there. So all these things are going to be dynamic, and then of course this microgrid is going to be connected to the main grid also here. But here we want to operate this microgrid as a self-sustainable and taking into account the transient or the dynamic conditions, and to make it more self-sustainable, here we will need one distributed generator which should have the capability to dispatch the active and reactive power as per the requirement within this microgrid, to make it more self-sustainable and reducing the demand which we required from the main grid. So that point have been considered here. Now another very interesting point, the second point, it says that we need to have differentiated definitions of grid connection requirements for the various types of generator because of their different operating characteristics. When we discuss about the integrated renewable energy system based on hydrogen as an energy carrier, that was one example. There we noticed that each and every component, they were having very different operational characteristics. Due to that, when we want to make the grid connection for different type of generator, right? So we were going to require different type of definitions or the codes or the regulation depending on the source which we are going to connect. So that is also a very challenging also. Then we need to establish shared technical standards and protocols, okay, which will ensure open access, enabling the deployment of equipment from any manufacturer. Then this point is very important, and we discussed this point in the last lecture also, how we have to develop ICT system for utilizing innovative service arrangement to improve energy efficiency, control, management and trading. Yesterday, through this SEMIA project, we have studied about the energy efficiency, okay, and for that energy efficiency, we used ICT infrastructure for shifting the operation of non-critical power intensive load. So similar ICT infrastructure which we can use in this microgrid also for controlling the power flow from different sources, but at the same time doing the trading within this microgrid also. For that also we will need information communication technology infrastructure. And now when we are having all these different type of sources with different operational characteristics, and then of course what I mentioned you, we will be integrating them in the existing grid, and they are going to be mainly operating on the AC microgrid architecture. So we have to make it that how successfully we interface the new and old design of grid equipment, so that interoperability of operation and control arrangement should be there, right? So considering all these factors into account, we need to develop some infrastructure or new architecture design for that. So that design we will study today. Is it okay? And today's our focus will be how we have to operate future distributed energy network using ICT infrastructure, taking into account the existing methodology, right? That will be basically AC microgrid architecture, which can help us for further integration or further promotion of renewable energy sources. As we know that in India also there is a lot of incentives are given and lot of policies are there for promoting solar photovoltaic system within the distributed network. So at this time the policy doesn't say that whether this solar photovoltaic system which will be installed on the rooftop, whether they are going to contribute only on injecting the power or they will operate to manage the power. So at this point, what I have observed through the policies, what the government of India has published, they have not shown or they have not mentioned that when we are having very high number of distributed generators, in this case, it is the solar photovoltaic system, how they are going to impact the power quality within the distributed network. So there is a lot of points which are not being carefully or technically addressed by taking into account the next 20 years future also. So that's why we need to have the young professionals and young engineers like you who can think for, let's say, for the next 25 years ahead, that if such type of system is, and of course they are going to be there, so what type of technical challenges, operational challenges which we are going to face within the network. So that's what here we need to have new architecture, new concept for promoting integration of solar photovoltaic system, and for that then of course we will need to utilize the machine learning for doing the forecasting techniques and the customer participation, because we have to see that in, let's say, in next 10 or 20 years how this system and how this architecture can help us. And then for that also we will need some innovative energy management strategy which can help us to increase the penetration, energy storage and demand response. And through SEMIA project yesterday we did and try to understand the demand response also. Then another next point which is a very, very important, that is effective distribution control for the benefit of power quality and reliability enhancement at the connection point. So here at the connection point, when this distributed electrical energy network, future network, when it is going to work and going to get connected to the main grid. So let's say if we take this as an aggregated one unit, so at this connection point, we have to see that how the active and reactive power is going to be managed within this distributed network by taking only the active power from the main grid and reducing the reactive power capability here. And then at the same time, we have to see that this microgrid, like, because here we are going to have very different type of operational characteristics, and of course we can do the forecasting techniques. So with the help of the forecasting techniques, we can have the complete detailed tentative analysis like how the power generation, load profile it is good. So due to that, how the power quality is going to be impacted. So that is a very, very important point. So this power quality, it is going to be correlated in two parts, maybe related to the active power and related to the reactive power also. So with reference to the real power, it may go on the harmonics also, whether we are in a position to operate at the synchronous frequency or not, or otherwise what type of harmonics will be generated and how it will impact the power quality of the distributed generation. Similarly, when we talk about the voltage quality here, so the voltage quality is also going to be very important because it is going to impact the voltage variation to the main grid. So therefore, here you see with the help of the forecasting techniques, when we will study that how the renewable generation is going to be there, how the load profile is going to be there, with reference to that, how this power quality parameters are going to be changing. And then when we are taking this complete microgrid as a future smart distributed network integrated with the main network, let's say if we take this point of common coupling, right? So we have to see that at the connection point how this active and reactive power management is happening. Okay, so this is a really, really interesting point when we are talking about the sustainable technology development and especially within the distributed network. Now here we discussed many things here. So to have integration of all these different things, different parameters, we need to use system engineering approach to study the operational integration of distributed generation and active customer participation. So here active customer participation, it is basically going to be like most of the houses in future. They may have building integrated energy system, for example, the solar photovoltaic system, and due to the IoT techniques, we may be in a position to shift the load operation of the selected non-critical power intensive load, taking into account some incentive based demand response. So then that's why we call it here active customer. And with reference to that, we studied in the last lecture. So you see, when we are talking about smart distribution infrastructure, how it is going to be there. Now here, so this diagram is from one of my research article. Okay, it was published long back when I was working in South Australia. So here you can see that. So what the discussion which we did, so this discussion is mainly focused on this distributed smart grid network here. And you have to see, like, because you have good understanding and you got some very good inputs from Farooq related to the machine learning techniques also. So you can see that how those machine learning techniques which you have learned or which you have got some idea, right, how you can implement in this operation of distributed energy network for making it more smart and operating it as a microgrid. So here, what we defined here, let's say within the distributed energy network, we want to promote distributed renewable energy sources. At the same time, we want to do the demand side management, that also we discussed. So how all this and of course the energy storage are going to be there. So all these different components, right, need to be automatically controlled. So here you can see that one should have microgrid central controller, okay, which should be in a position to manage the power flow within this network by reducing the demand on the network. And of course we know that this microgrid may not be in a position to fulfill the complete requirement of the power. So we are going to get some of the power from the main network, okay. So that has to be limited to the real power. So when we are limiting that to the real or active power, but managing the reactive power locally, we are improving the energy efficiency of the upper side network also, and having more energy efficient operation. So now here, this is a very interesting point, because our existing power system network, right, they have the limited capacity, okay. And of course, as per International Energy Agency analysis, it has been said that, I don't remember the exact figure, but the huge number of electrical network or transmission lines will be installed, okay. But with what purpose? But with the purpose of to have more integration of sustainable energy technologies, for example, high capacity wind power plants and like that. But now here, we have the focus that within the distributed network, how we can manage, right, the power generation, load management, reactive power management within that particular microgrid. So here you can see such type of microgrids, there will be n number of microgrids, they will be operating in parallel. So every microgrid is going to have its own central controller. Then from the supply side point of view, this is going to be a point of common coupling, and this controller has the duty, right, how this local management is going to be there. For doing the local management, here you can see that how the data informations from different sources is going to be collected by this microgrid, and how the local management of the power going to be there, that we are going to study now. Okay. And what is the objective? Objective is to reduce the demand on the main grid and to make ourselves more self-sustainable communities. That was the focus that was the main focus of our yesterday's lecture. So here you can see that we may have different type of energy storage. Some of the sources, here this is a very good point, some of the sources is going to be dispatchable power source. Otherwise, we may not be in a position to do the complete power management here. So how we are going to do that one? So now this diagram is further modified here. So I believe that this diagram will help you in understanding how the different electronic components or power conditioning devices are going to be required in integrating such type of source. So I believe that many of you are having the background in electronic devices, components, and electronic engineering. So you can see that how different power conditioning devices are required for integrating all these different type of sources within the microgrid. So here I will explain you. Let's say this one unit is there, or one distributed electrical energy network is there, which is connected to the medium voltage network. So here all these different sources, they need to have their proper integration and intelligent operation also. For that we need here at this point of common coupling microgrid central control. So this microgrid central controller has the responsibility to control these local microcontrollers, okay, for different sources and the loads also. From the utility point of view, utility is going to contact with the microgrid central controller also. And for that, then we, of course, we need some distribution management system and load controller also, because we studied yesterday for doing the demand side management. So how we are going to do that one? Now that is the main question now here. I am going to explain you what type of characteristics which we need to implement in doing the operation of this dynamic operation of this microgrid with reference to all these different conditions into account. So here, if you might have carefully observed here CHP is there, combined heat and power plant unit. So we assume that, let's say, heat requirement is also there. But let's say if we consider our Indian tropical condition, we may not need to have the heat within the distributed network. So we can have maybe simple gas turbine or micro turbine also. So this micro turbine or CHP unit going to be in a position to provide the power within this microgrid as per the requirement. Okay, so that requirement, like how it is going to be fulfilled, and that how this microgrid central controller is going to communicate that or going to implement that, that we are going to study here. So here you might have observed that. So here we have n number of components with different operational characteristics, and this microgrid central controller here. So this microgrid central controller is having a very important role. Okay, it has to enable the decentralized active network and using the local control of distributed energy resources. It means that if we go back here, so here it has the duty, the purpose is like to have the reliability of power supply within the distributed network. Okay, then by giving the promotion to increase the consumption of renewable energy sources, then of course to have more autonomy for local system management, and it should have the capability of islanded operation and synchronization to the main grid. So here you can see that I have that work also, but we don't have the time. So if suppose this microgrid is in a good position to operate under the islanded condition, right? So this microgrid central controller should have that capability here. Okay, so that is the important point here. But let's say when again we want to connect it back to the network, then it should be in a position to do the proper synchronization also. So that's what in the first lecture we mentioned about the off-grid system, and then that off-grid system needs to be connected to the main grid system, and it is going to happen into the future. It means that this microgrid central controller, it is going to play the major role on that one, right? So here you can see that how this future sustainable technology development is going to be there, and how this future sustainable technology development is going to be integrated into our existing energy system network. And many of you are having very different background, that I know that. So in future, as per the statistics, most of the engineering requirement is going to be in the sustainable energy technology, because there is a huge requirement of going to be huge requirement of professional engineers in next 10 to 15 years. Okay, because our complete energy infrastructure is going to be through sustainable energy transition. So while doing your work, okay, you can focus that how you can contribute your expertise towards that, and of course finding appropriate employment opportunities also. So I mentioned this point also, right? Energy efficiency by coordinating consumption of energy. Forget about it, let's say the power. And for that already we have seen a big project, that's scalable energy management infrastructure for aggregation of households. And now this system, the microgrid which we are talking here, let's say, is going to be a test system for future technology. Because in the future, whatever the technologies are going to come, like fuel cell, electric vehicle charging, or many other distributed sources, that will be integrated within this distributed network. Now, the very last point, this point here, is very important, right? That point, it says that virtual power plant and for the trading. So from the network point of view, now from the network point of view, this complete system with different operational characteristics integrated together within the microgrid. So this microgrid should have the capability to operate it as virtual power plant. And we use that word in yesterday's lecture also. So now you can see here that how this virtual power plant is going to help for efficient participation, not only from the power management point of view, but from the energy market point of view also. That we are going to discuss very soon. Now, if we go back here, we have seen the what operational capability is going to be required for this microgrid central controller, but at the same time, we will need to have capability of controller in each area. So this is a again very important point. So when we sit within the limit, okay, and frequency variation within the limit, and it should be in a position to optimize generator schedules and controllable loads also, right? So that the data which will be collected from each controller is going to be used for forecasting energy demand and availability of renewables also, and then accordingly doing the optimization of this network, okay, to have the minimum interruption within this local area, as well as with the main grid also. And within this microgrid area, we need to maintain complete power balance and of course the energy balance with reference to the time both also. So that point, right, is very important. And now here you can see that the points which I discussed, what the role is going to be there, like, and how their efficiency and effectiveness is going to be there. So unit controller is going to be very small. Cell and microgrid controller will be at that above that level, and then above that we will be having the distribution management system, and at the transmission network at the higher level we are going to have this higher energy management system, right? So for doing that, we need to develop some mechanism for trading, tariff, real-time control, and automatic control. Now I am going to explain you. I have given you very high level overview about the technical challenges, operational challenges which we are going to face within this distributed network when we are operating as microgrid. So when we are operating as a microgrid, and this microgrid may be owned by some utility company or maybe some another company, right? Because it is going to be a big technical challenge. So the company which is going to be operating or this system as a microgrid, right? So they also want to make the profit also. So how that business model is going to be incorporated with reference to the variation into the load, that we are going to discuss now with some flow chart. Okay. Now here, this is a very interesting flow chart which I have developed maybe around 15 years before, and this diagram or block diagram I can say is very interesting. Okay. Now I will explain here what it says: system and market operation in a smart grid for distributed generation and real-time processing. Okay. Now we have this microgrid central controller. I will go back a little to the previous. Try to understand this one. This will give you really a very good overview to you how we have to do the operation. Okay. So here, this is a microgrid central controller. Okay. So this microgrid central controller has the duty to do the power balancing within his distributed network, and we want to make it more smart. And of course, we will put some information communication technology, IoT based system for data communication from one point to another. Now here in this microgrid central controller, we have many sources: photovoltaic, this plant, this plant, this plant, energy storage, and like that. So every unit, let's say take a micro turbine, it may have some capital investment, and based on that capital investment, lifetime of the project, energy cost, we can calculate, that is a levelized energy cost. So now here the promotion will be given to the renewable energy sources, demand side management will be there. So now the load variation is happening here, and renewable generation is also varying. Now this microgrid central controller has the duty to overcome the intermittency of the renewables load dynamics by taking the power from the dispatchable power source, let's say this micro turbine and the CHP, or maybe from the fuel cell. So how it is going to be done, that has been explained in this block diagram. So every dispatchable power source, for example micro turbine or the CHP, it is going to require some fuel also. So naturally some operational cost function will be there, correct? And the price of this DER, distributed energy resource, we can say as a dispatchable power source, its price is going to be depend on the operational cost function. When this microgrid says that needs more power from the sources because more load dynamics and more load generation is there, so there should be some energy pricing balance also because everyone want to make the profit. So this source may offer some price to the microgrid controller. You can say that next 1 hour, due to the forecasting of the renewables, forecasting of the load, how much deficit is going to be there. Based on their deficit, this unit can calculate how much operational cost is going to be there, right? And taking into account initial capital cost and other functions, levelized energy cost. To make it more profit, the price will always be offered above the levelized energy cost. So that price will be offered to this microgrid central controller. So that here we have shown only one unit, but then previous slide we have seen that there may be multiple sources there. So the multiple sources, they may offer the price. Then this microgrid central controller may agree to that price or may not agree to that price. But that agreement of the price is going to depend on technical characteristics also. That we will see in the next slide. Okay. So then let's say then this microgrid central controller offered some other price. Okay. And depending on its group functionality that we will study, then this unit may get accept that price and provide the power output based on some generation settings and the load. Are you able to understand? So this is a very interesting point, how this complete mechanism is going to be happening within this microgrid with reference to the cost function also, but now we will study the technical function also. But this is a really interesting how this one need to be, now you have to keep in mind how this one need to be implemented with the technical functionality, that's what we call it group functionality. And if we take that group functionality into account here and the cost functionality into account here, then you can see that how the system variation is going to be there. So to talk about the sustainable energy technologies and their development, we need to consider like this such type of microgrid approach also. So now here you can see there is a one graph. Okay, it may not be necessary to be linear, but just to explain you, I have kept it as a linear function here. Here we have the energy price from that particular dispatchable power source. Now you have to keep in mind, from that particular dispatchable power source, where we want to have more and more renewables. Okay, so those renewables are going to get the priority. Okay, and their tariff mechanism will depend whether it is a feed-in tariff mechanism or any other like that. But the main control of the power balancing is going to be from the dispatchable power source. So how it is going to happen? Like here we have the energy price and here we have the active power output. So with reference to the previous slide, you might have noticed that the price is going to be basically depend on the operational cost function. And when we are getting more and more power output, more and more fuel will be consumed, right? So naturally, the pricing is going to be increasing if you are consuming more and more fuel. Or why we are consuming more and more fuel? Because we want to have the more power output. So now here you can see that. So within that particular distributed network, based on your forecasting techniques, which you have studied at very high level or got some understanding, we are in a position to understand how the load demand is going to be predicted, how the renewable predictions are there. So short if we use that short-term prediction, based on that short-term prediction, we will be in a position to know that in the next 15 minutes or 30 minutes, how much power demand is going to be there and how that power demand is need to be fulfilled from this dispatchable source by limiting the power supply from the main grid. So let's say the system is operating, or that source is operating at this point, and the price was this, and then of course here if we come to the second point or the second graph, so this is, here we have the frequency and here we have the power. So in our engineering terminology we call it as a group functionality. So this group functionality, I teach that group functionality in one of my courses where I teach stability and control, especially with increasing penetration in renewables, and we derive all these equations also there, but here we will not do that one. So let's say here we have some setting here, right? Generation setting was here, and with that generation setting, the system was operating at the rated frequency. But now, due to change in the demand within that microgrid, the change in demand within that microgrid, okay, so microgrid central controller has to request dispatchable generator to provide more power. So if I am an independent generator operator, I will see that whether it is profitable for me to sell the electricity or not, because that system also want to make the profit. So then that profit is going to depend on this cost function. Let's say initially we were here, okay, and system was operating here at the rated frequency, but now power is increased. So new power setting is here. Earlier power setting was here, but the new power setting is here. So if we go to the new power setting and if we don't change the settings or input setting to this generator, frequency will drop based on this curve. Okay? So if we have this drop in the frequency based on the increasing demand, that is not allowed. Right? So that is not allowed because we want that every system should operate under the standard frequency or a standard conditions. So if we take that standard condition into account to avoid that drop into the frequency, right? So new setting is going to be here, and this graph and this graph, this is in the having the same slope. So this graph will move in parallel to this point, and then it moved to this point. Okay, then with reference to this new point, because it has to move into parallel to overcome that drop in the frequency, and with this new power setting, you can see that the price is going to be different. So that price with the new setting is offered by that distributed generator to this microgrid central controller. Okay, so this is a very interesting point here. You can see that we are trying to do the proper balance between the energy pricing and the power quality or the technology terms. So this work I did maybe around 15 years before, and now the same approach is going to be implemented into the AC microgrid architecture. So I feel very happy. And I was teaching this one when I was working at University College London. Now here you see, with reference to this new setting, this price is offered to microgrid central controller because now it has to consume more fuel. So that then depends whether microgrid central controller is going to accept that price or not. Maybe earlier the price was here, but now the new price is this much. You got the point now? So if that microgrid central controller doesn't accept this price, says that no, I can buy the power from you, or basically it is for a very short period of time, let's say 15 minutes. So if I buy the power and then into multiply energy, time and then energy, right? So maybe say that I don't want to have that much price, I want to have this much price, right? So then this generator, distributed generator operator is there, can say yes, based on let's say this price what you are offering me, I have this much setting and I can contribute. So here then he can say that I can contribute only this much load, not the complete load from here to here. So then this microgrid controller has to go to another distributed generator. Then this microgrid central controller has to go to another dispatchable source here, right? How to do the balance. And then the cost function of this another unit and the true functionality of another unit is going to be different. So here you can see that how the continuous power balancing with energy pricing dynamics is going to happen. Is it okay? Are you able to understand? So here, now I have given it very high level, then of course we need to do a lot of calculations and a lot of mathematical modeling for all system components and like that. Okay, then it requires a lot of effort. But here, if you are in a position to get high level knowledge or high level information, how the dynamics is going to be happening within this distributed network with reference to the load variation, and how this microgrid central controller can help us to managing that power balance within this distributed network, taking into account for profit or the income of this dispatchable power generation sources. So this is a very unique work which I did long back, and I tried to give you at a very high level so that you can get more information, but then we did some implementation on this work also. Okay, so this what we here you see how this is going to be the continuous function for different dispatchable power sources, and these functions can also be implemented within the off-grid system also. Let's say within the off-grid system, if we have n number of sources and there will be some controller and n number of sources owners, may be different, okay. So everyone, whenever they are installing any technology, so nothing is free, right? Everyone want to make the earning, whatever the capital investment we did, we want to recover that one, right? So for that you see how this pricing function with reference to the operational cost function, and then how this microgrid central controller can manage, right, by taking into account this functionality. In real practice, this graph, okay, price versus active power may not be linear, but this one, this graph, frequency versus active power price, is always linear. And now here you see, to distribute or to go to the new setting, this group function is going to move in parallel. So its slope is going to remain the same. And then this same group functionality is going to be used for sharing the load among different distributed generators also. For example, if I take the change in frequency on this axis, power on this axis, let's say dispatchable generator 1 this side, dispatchable generator 2 this side. So this may have this characteristic, this may have different characteristics. Okay. So now let the system is operating at rated frequency here, let's say f0, but now we have drop in the frequency, let's say f1, let's say that is the change in the frequency. So this change in the frequency now, why it is happening? It is happening because we want to have more and more sustainable technology or nature dependent technology integrated into the network. So the load is changing and the load is directly proportional to the change in the frequency. So this, based on this change in the frequency, we will see that how the load distribution is going to be happening between these two different generators. So here just I have shown you the technical function, right? Let's say P1 here and this side P2 here. But on this one, we can implement this pricing function. Then based on their pricing function and the agreement with the distributed generators, maybe we can have different settings here. Let's say this generator is in a position this much, and then accordingly how we have to dynamically adjust that one, right? And that dynamic adjustment is going to be based on the pricing accepted, but with the focus that the operational frequency of that distributed network or microgrid should be at the rated frequency. Are you able to understand? So in future, right, our distributed energy network is going to be operating, in my opinion, using this concept. And to implement this concept, you have to see that how you can contribute using your technical knowledge. We are going to require a lot of power conditioning devices. So let's say very simple. Let's say now here you can require many type of controllers, DC-DC converter, DC to AC converter, and like that. So there and then some of the sources I have taken, let's say more like a rotational sources, but some of the sources may be non-rotating type. But non-rotating type sources, for example, fuel cell or battery banks, they can also contribute towards the dispatchable power source. So when this non-rotating type sources, which we are integrating it within the microgrid, we will need power electronic component or electronic component. So this non-rotating type component, mainly the stationary, will be having DC. So we will need DC to DC converter and then DC to AC converter. So that DC to DC and DC to AC converter should have functionality to operate as virtual synchronous generator. To operate that as a virtual synchronous generator, then it is going to be the big challenge. So with reference to that, one of my students, he did the work and then he implemented that work, right? And his thesis was awarded as best thesis by Agadar Energy from Southern Norway. So because here you can see that, of course now I had to motivate you for doing the work on sustainable technology and using some controller techniques and like that. But when we want to do the real work, okay, how we have to get it focused. So he did that work especially at this level, and his thesis was awarded as best thesis also. And maybe let me see if I can see here the work. So he, or maybe this is my project. So then you see, maybe through the block diagram you can understand more clearly. Mostly our system will be three-phase. So three-phase to, when we have three-phase system and a rotating system which we are converting, and we have to integrate some non-rotating system also. So then for that we will need this Clark and Park transformation. And I believe that those who might have been working on electronic components, and especially with reference to the three-phase system, so they know that how we have to do the conversion between three-phase to rotating two-phase, and then rotating two-phase to stationary two-phase system. And that stationary two-phase system, right, it is going to be for the stationary sources, non-rotating sources, and they have to convert it into back. And when we are controlling that, you see, then we have to implement this frequency droop characteristic. So we implemented two frequency droop characteristics there. One was related to the active power and another one was the reactive power. So here it may be little very high level for you, but I will share with you what I can say, the published work of that candidate. Okay, that is very, very good work. Okay, so now you can, means taking into account very high level how the idea which we discussed here, when we want to implement this into the work, right? So basically most of the devices need to be operated as virtual synchronous generator. And their virtual synchronous generator operation, like if we go back to this slide, okay, let's say this energy storage or the fuel cell. So here power sharing, right, based on the their operational characteristics, price versus fuel consumption capacity or characteristics, or let's say cost function and frequency versus power group function. And then they cannot immediately go and supply the power, but the decision has to take by microgrid central controller, and to take that decision from the microgrid central controller, right, it has to be based on the pricing. Is it okay? Are you able to understand, or very high level? So yesterday one participant, she was asking about the controller which need for this, let's say any of the source, right? How we can develop some embedded system based on that functionality. So here you can see, right, in that control system or embedded system, right, all these things has to be done automatically, right, without human intervention, because it is going to be making the decision in fraction of seconds of time. Right? So for that, then when we are developing some controller, so basically it is going to be some embedded, whatever the algorithm we are developing, we need to get it embedded in a device. Like for example, yesterday we talked about home energy management gateway. So that home energy management gateway decision was to this Devolco product gateway, and it was of our mobile side. So in that we implemented all the functions, right? What we want, how we have to do. So similarly, these functions, not only these functions, but the functions which are going to be required, let's say, let me go up. The functions which may be going to require here, that need to be programmed in that embedded system. So you can see that how is what we are discussing, how we need to make a proper programming using, let's say, Java or any other platform, getting it embedded in that one, what information we need, what outputs we need. So that is also a very good work. So here you see, this is a grid. Okay, maybe now I will try to explain this diagram with reference to this one. We have the grid, okay, but then grid is always AC. We will make it AC to DC because we want to reduce the reactive power from the main grid, only active power. So we will operate it AC to DC and DC to AC converter through that grid. So here you see, when we are talking about here the interface with the common point of coupling, we will need AC to DC and DC to AC converter and inverter, and their role will be mainly to take the active power from here. Okay, and then here when it is going to provide the here basically DC to AC, so this source with reference to the microgrid is the main source. So it is also going to have a droop functionality. So that droop functionality is having the very high slope like this. That needs to be implemented there also here, because we have to do the load sharing. And within this one, right, is not necessary that 100% fulfillment of power is going to be there. Some of the power will always be taken from the main grid. So that main grid power we have to minimize, and to improve our efficiency, we will make the reactive power zero, only take the active power here. That's what my student implemented there. So then here this system, or with reference to this point, this system is going to work as a very high capacity generation source, and it is going to have the droop functionality like that, but that slope will be very high, just like a parallel to the power. Is it okay? So here you can see that when we are doing this integration with medium voltage to the lower voltage, or connecting this microgrid with objective of energy efficiency and making this system more sustainable for the power, right? Here we need to include AC to DC and DC to AC converter, and in that DC to AC converter, when we are controlling their PWM switching signals and like that, so that controlling of the switching signals is going to be based on group functionality. Is it okay? And now then again the power dispatching from the main grid to this microgrid from here to here, again it is going to depend like how much generation available here, how much load demand is there, what is the deficit. We are not in a position to fulfill this one, then only we will take it from here. So we are going to have a reliable power supply. And for that, then of course this microgrid central controller here need to have the information for next 24 hours ahead also. Accordingly, then from the energy balance point of view or market balance point of view, can communicate that information, okay, to the more upper level here to the distribution energy market operator. So I tried my best to explain you like how the microgrids or distributed generation, which we studied or tried to study, understood in previous lecture, then how we have to integrate them within the main energy network. So learning from today's lecture is going to help you, right, towards the sustainable technology development. And of course, we have seen that not only the Indian government, but most of the governments in all over the world, they are promoting distributed renewable energy sources, for example, solar photovoltaic and like that. But now we can see that how the technical and operational challenges are going to be there. To overcome those technical and operational challenges in next 20 years, we may need to find out new architecture for operation. This, in my opinion, this new architecture of operation is going to be based on AC microgrid. That's what we discussed today. And in this AC microgrid operation, now you can see that how you can contribute towards the different aspects based on your academic background and interest also, and how you can involve your young generation or the students, right, for getting trained and contributing in such type of things. Do you have any questions or any doubt? Just please feel free, because we need to have some discussion. Always it is not good to have unidirectional information, because now we are talking about the microgrid. So we are talking about bidirectional information. So we want to have the lectures also bidirectional, not unidirectional. Okay. So active engagement is always important. We are doing the active engagement from the consumer side also, active engagement from the distributed sources to the main source also. So in the same way, I need some active engagement from you also. Yes, please. Speak a little loudly. Means members means. Oh, you mean persons? Oh, so that persons, it depends, na? Like, I mean, if because it is at the university level, it was what was there. So we collected all the information from the utility company, and then that student, based on those information, developed its algorithm, switching signals, and like that. So that one was a PhD work. So basically, it is I think one PhD student, he did that work, and then couple of master's students were also involved in that one. Yeah. And of course, then if suppose we want to have such type of system in our Indian condition, for example, so you have to consider, let's say, because you can take one typical distributed network, and for that typical distributed network, if utility company is in a position to provide the network parameters, okay, then we can do the load flow calculations of that area, and after doing that load flow calculations of that area, we can calculate how much energy storage, how much solar photovoltaics are going to be there. If suppose some fault is happening, how the islanding condition is going to be there, and how we can use some machine learning algorithms for that one. So I have one more work. Let me see here. Because you mentioned that point very good. We did some work for one utility company. So let's move here. I was thinking to present this work also, but we have limited time. So, but I will share this work with you, okay? Forget about this, forget about this, forget about this, forget about this one, forget about this one, forget. Now you see, oh, it's not coming. You see. Now you said that how many people or how we need that. So this is a typical Bangladesh National Power System network, okay? And one of my student, he did the work, and then he selected one portion of that work, okay? And from that portion, then he collected all the system parameters there. And in the system parameter, then based on this all this condition, he did some calculations for finding out the energy storage also, okay? And let me see if it is there. Yeah, 1 minute, I will make it proper. You see, then he used GA algorithm for doing the optimization, finding out the appropriate energy capacity. For that, then he used this all cost function. Then he has taken this real network here. Within that network, then he calculated all different type of functions. Okay, based on that, then which type of energy storage may be economically viable, etc. Then within that section, if it is the islanding operation, we want to operate that as a microgrid. How much DG capacities are going to be required, that have been calculated, and then he made one small area also here. Here you can see, but if the fault is happening in between, or maybe if that area we are operating as the islanding condition here, right, how the situation is going to be there. So it's a lot of things are there. I will share the article of this work which have been published couple of days before, and maybe if you are interested, will be very useful for your for further studies or of your interest also, because we have limited time. Otherwise, I was planning to present this work, and I have requested my student also to send his MATLAB and GA codes, like maybe we can run here, but it seems like there was some problem with his computer, so I was not able to get it. But the article, few days before we published, okay? So that article is open access, and you can refer that, and in that article, all technical equations, mathematical functions, it has been given. And maybe if I have that article, I will show you. You can download that article. It seems some problem. So this is that article. You can just search in neural computing and applications, AI techniques for optimal control and operation of power system. In that issue, this article has been published, and which is quite relevant to our course also. Okay. So, do you have some time for it, or we'll go for lunch? Yeah. Okay.
All participants need to write the exam and fill that feedback form also. After that, give to Priya.
में से इसको इस फिंगर का है ना, और उसको पर से so very good. I believe that you are busy with your task which have been given for your evaluation, and I wish you all the best in that task. And you please carry on. I'm just giving you very high level concluding remarks. Right, in today's lecture we tried to integrate the learning from previous lectures and how this different sustainable energy technologies, especially within the distributed energy network, how we need to integrate, what type of microgrid architecture which we need from energy efficiency point of view, energy marketing point of view, or making the distributed network more self-sustainable. Okay. Then here you have seen that it is not like one engineering domain knowledge. We need to integrate multi-engineering domain knowledge. It means that we have to consider United Nations Sustainable Development Goal 17, which it says that co-creation of knowledge together. So it means we have to create the knowledge by using our individual expertise, and we have to get the benefit from each other. And of course, then you studied about machine learning also in this GIAN course. So this machine learning techniques what you have studied, right? So going to be very useful for further development of sustainable energy system, and especially taking into account the case of sustainable electrical energy network. And we have seen that most of the renewable energy sources or sustainable energy technologies are going to be electrified. Okay, so I believe that some of the learning from this course will help you in contributing effectively for future generation and to make our society more sustainable or sustainable community. And Farooq did wonderful work by teaching you and giving the information about machine learning knowledge in a harmonious manner, and providing teaching to your students also, and for doing further research. Okay, so thank you and good luck for your coursework or the evaluation what you are
Good afternoon to one and all. It's my privilege and honor to stand before you today as we will conclude this enlightening journey of 5 days GAN course on sustainable AI, employing machine learning for sustainable technology development. As we bring this course to end close, we celebrate not just the conclusion of the session, but also the sharing the knowledge, collaboration, inspiration has been driven forward for the field of sustainable technology development. Throughout this course, we explore foundations and advanced topics of employing machine learning and AI for sustainable energy systems, from forecasting technology of renewable energy to the optimizers and power energy systems. We'll learn critical challenges, opportunities of sustainable energy development, and hands-on sessions on building the developments of time series forecasting models and AI-based development. As we now see the memory of last 4 years, 4 days, what we have done with a short AV. Yeah, thank you. Just a short memory, like last 5 days, what we have gone through, so and our learning journey. So let's carry forward the knowledge of what we have gained and applied for real-time challenges. Now it's time to invite the dignitaries onto the dais. Now I would like to invite our Dean IRA, Professor S. Srinivas Rao sir, onto the dais. Give him a big round of applause. So it's my honor to invite our guest resource person, Professor Mohanlal Kole, sir, Professor of Faculty Engineering Science from Agder, Norway University. Please come on to the dais, sir. Now, now I'd like to invite our beloved HOD Madam, Professor D. Bakla, ma'am, to come on to the dais. Give her a big round of applause. Finally, I would like to invite our GAN course coordinator, Prarik Hashmi, sir. Please come on to the dais. I request everyone kindly raise for the national song. Vande Mataram, Vande Mataram, Sujala, Suphada, Malaya Shitala, Satyashyamana Mataram, Vande Mataram, Shubhrajyotsna Pulakitaya, Suhasini, Sumadhura Bhashini, Sukhadam Varadam Mataram, Vande Mataram, Vande Mataram. Thank you all. I invite Professor Farooq Hashmi sir to share the summary of GAN codes on sustainable AI. Now I would like to invite Dean R&D Professor S. Sirish Hari sir onto the dais. Please give him a round of applause. Thank you, sir. So I request Farooq Hashmi sir to give the summary of the GAN course.
Mane sir and respected our beloved HOD madam, Professor Vakula madam, and our speaker Professor Mohanlal Kohli. So good afternoon everyone. So as we conclude this GIAN course on sustainable AI, employing machine learning for sustainable technology development, it is a pleasure to reflect on the journey we are shared over the past several days. We explored a wide range of cutting edge topics, gaining both theoretical knowledge and practical experience in applying machine learning and AI in sustainable energy systems. We begin with the introduction to sustainable electrical energy systems and machine learning, laying the foundation for the integration of AI into renewable energy technologies. Discussions and case studies demonstrated how AI can help with forecasting renewable energy productions, optimizing power flow, and enhancing grid stability. Participants had the opportunity to engage in hands-on exercise such as using Python and machine learning libraries for energy forecasting, data pre-processing, and feature engineering for energy data set, and building in the time series forecasting models to predict the renewable energy outputs. We also explored energy storage systems and battery management, learning how they contribute, especially for grid stability, sustainability, and resilience. So, discussion on grid cyber security highlighted the importance of securing smart grids with AI-driven intrusion detection system, which are becoming essential as a renewable energy adoption grows. One of the course highlights was the simulation of optimal power flow model for grid with integrated renewables, showing how to balance loads and manage energy efficiently. The final discussion on AI-driven solution for charging station management and energy trends and research directions gave us a glimpse of the exciting future of AI in sustainable technology. And throughout this course, we witness not just the depth of the knowledge shared, but also collaborations and engagement that make learning meaningful. So your participations, questions, and insights have been invaluable in forecasting and fostering a rich learning environment. As we move forward, let us apply what we have learned to innovate, improve, and accelerate the adoption for sustainable technologies. So, together we have the tools and inspirations to drive meaningful changes in the critical field. Thank you, and I look forward to seeing how each of you will contribute a more sustainable AI powered futures. Thank you, one and all.
Thank you, sir, for your complete summary. Now it's time to listen from the participants. I would like to request the participants to give your feedback.
Good afternoon. I am Dr. Kavita, Professor and Head from M. Kumarasamy College of Engineering, Karur, Tamil Nadu. First of all, I would like to thank Farooq sir for giving me this opportunity to attend this GIAN courses. And actually, first of all, I admire about the topic because I am from electronics background. I want to know how the sustainable development is implemented by using machine learning. That's why I have applied this workshop. And during that, the very first day, Gole sir started his funded project explanation along with the Sustainable Development Goals, SDGs 17 and 7. He has explained, he has started from that Sustainable Development Goals as well as his project, and how it is implemented or how it is integrated is explained by Farooq sir. Actually, three different versions we have seen in this GIAN course. Normally, when we are allocating some projects to our scholars or our students for minor projects, we are giving in topics in our domain, and as well as whatever the papers we have published, from that we have taken the problems, as well as we have taken the problems from the industries. But now only I can understand that sir has explained the full funded projects, from that how the objectives is developed, from that objectives how the architecture is developed, from that architecture how the minor projects or normal projects or some modules will be given to the scholars as well as students. So like that I have learned. From this workshop, the takeaway point for me is how the sustainability goals are integrated with our engineering topics. That one. And next one is how it is implemented by using the recent technologies like AI or IoT or deep learning or CNN, like that. They have given us several sessions. So in every session, both of them have interacted with us, and they have given lot of ideas how to enhance this and all the things. And not only teaching part or not only knowledge sharing part is given, they had a session for interaction. So for during that interaction, every question was answered by Gole sir, and he has given a lot of ideas. So this is for the takeaway point from this GIAN course, as well as about the hospitality. From the day one, we have daily take care by Jansi ma'am. So thank you all for giving me this opportunity. Thank you.
Thank you so much, ma'am, for sharing your feedback and your views, how you like explored these 5 days. And thanks for coming from long away, because ma'am came from Tamil Nadu, so she stayed from long journey, and thanks for joining us. Thank you. Still, any other participants want to share their feedback? Yeah, please.
Respected dignitaries, my fellow participant, good afternoon. I am first of all very thankful for NIT for providing me opportunity for this wonderful course on sustainable AI. I am thankful for NIT. I am thankful for authorities of GIAN, HOD ma'am and Farooq sir. And actually, India has committed carbon-free nation by 2070 to fight against the climate change. So I'm confidently, I can say that this course is contribution to the nation's goal. That's a great thing. I'm very much thankful for that. And I'm thankful for our guest Mohanlal sir. He has shared his hard work, his research, and European Union funded projects and all those things, which are very enlightening and which has given leads for further research scope in this field actually. I'm thankful for Farooq sir. He has actually explained AML right from the basic to the hands-on. It was very wonderful. He has shared and how the AI and ML can be implemented in the various fields, and he has shared a lot of case studies of various countries how they have implemented AI and ML for sustainable green energy actually, and how we can do further research in India as part of contribution to the nation. I'm very much thankful. All the facilities provided were very wonderful, I can say, very nice. Food, accommodation, Farooq sir and their scholars, Jhansi Rani ma'am and Priya ma'am, they were very kind to us for our queries. They were every time they were available, and they have meticulously done very good work, very hard work to provide us a good environment for what I can say hassle-free and smooth learning. I'm very much thankful, and thank you for everything I can say. Thank you.
Thank you so much for your wonderful feedback, sir. Still, any of the participants want to share? Yeah, please, sir.
Respected dignitaries, definitely this workshop has been a highly enriching experience and providing us a valuable takeaways and inspiration to drive future growth. I'm also thankful to Dr. And Professor Mohanlal sir for delivering a wonderful sessions and sharing his knowledge with us. I also appreciate the excellent support provided by Dr. Farooq sir and Jhashi madam for this workshop. As the first time visitor to NIT Warangal, I must say that it was a great experience. I look forward to participate in the future programs and hope to be invited again. Thank you. Thank you.
Yes, thank you so much, sir. Like, sir came from Maharashtra. Thank you. And with your family, you came and you stayed for 5 days. Thank you so much, sir, for your coming. And still, any other participants would like to share their views? Yes. Please, like, one after another. Welcome.
Good afternoon, one and all. I am Pallavi Patil from Sharad Engineering College, Kolhapur, Maharashtra. As an computer science student, before attending this course, I didn't think that I can have a very much opportunity to do in very much work in this field. So after understanding all this concept and all the project, Kolle sir have explained very patiently and very deeply. They have explained all the things. So I have got very much meaningful insights that I can work in AI in this field. How can integrate AI in with this field? So basically, I am working as an assistant professor in AIDS department. So yes, I have successfully extracted much more problem statement with which me and my student can work in this field. Thank you, sir. Thank you for this important knowledge and valuable knowledge.
Thank you so much, ma'am. This will be useful for in future also. Still, Tangaraj, sir, you can.
Good afternoon, good afternoon, wonderful person here. So myself, Tangraj, I am coming from Tamil Nadu. I am working as an assistant professor in the Department of EEE. Actually, my research focus is on how to integrate the renewable energy systems in the grid network. Okay, so the title itself make me to register. So from the first day itself, it's make me very pleasure to stay here. Okay, so Sir Kole sir shared his knowledge very clearly, and I had many inputs from him. Thank you, sir. And in AI, I have only knowledge. What is AI? Actual, what is the meaning of that? Only I know. After coming here, I get to know what are the different learning methods behind that. So from that, I can hope I can apply that learning methods in my upcoming projects. And thank you for the Farooq sir for wonderful your knowledge and share with us. Thank you all, and for food and accommodation. Thank you.
Thank you so much, sir. Your Annie, ma'am.
Good afternoon to everyone on the dais and off the dais. Myself, Yorani from M. Kumarasamy College of Engineering, Karur. I want to say one important thing. Actually, I'm doing my research in nanoelectronics. This field is totally different from me. I have attended one online FDP from the same domain from my NIT Warangal. Actually, it was organized by some other department, but I forget the department name. From that only, I got interest to learn AI. So I started to learn AI, and I don't know where to apply and how to apply. And I came over here to get the knowledge and how to apply in this field. Actually, basically, I did my UG in instrumentation, electronics and instrumentation engineering department. But at present, since ME is in VLSI design, I'm working in EZ department. So I don't know where to apply AI in our application. But this FDP gave me a wide knowledge and how to get the applications and how to apply AI. Thank you so much for the organizers, Kole sir and Farooq sir. Thank you so much. Thank you for that. Thank you for your support.
Thank you so much, ma'am. So now I request Dean IRA Professor S. Srinivas Rao to speak few words on this occasion.
Respected Professor Mohanlal Kohli and Dean Research and Development Professor Sirish and Professor Vakula, Head Department of Electronics and Communication Engineering and coordinator of this 5-day GIAN course, Muhammad Farooq, and faculty members of Department of Electronics and Communication Engineering, dear participants and research scholars and participants who are attending through online. Warm welcome to all of you for this valedictory function of 5-day course on sustainable AI. And so my special thanks to Mohanlal, Professor Mohanlal sir, for showing interest to interact with our faculty members and entertaining them for preparing the GIAN course on sustainable AI and preparing the contents, and finally it got approval and he has shown a lot of interest to come all over from his country Norway and spending with us for 5 days and sharing a lot of knowledge and clearing your doubts and spending most of the time along with the participants, not only in the class lecture duration, other after lecture duration also he has made very nice interaction. He is a very nice gentleman. While speaking to him, we will get a lot of interest for speaking, as well as interest to know more and more knowledge, subject knowledge from him. He also worked on the solar photovoltaic systems and electrical grid systems, and he is also having vast knowledge in electrical engineering domain also, and how to apply this AI to all the major engineering fields also he knows. By interaction with him, we could able to identify that he is having huge knowledge in the AI and sustainable developing sustainable technologies for most of the electrical and electronics engineering fields. So I thank the GIAN local coordinators at IIT Hyderabad, Director IIT Hyderabad, and Professor Anil Agarwal and his team for closely monitoring the GIAN phase 4 courses. So these courses were first during the at the time of starting of this phase 4. This was monitored by IIT Kharagpur. After that, it was transferred to IIT Hyderabad, and they took a lot of interest to speed up the review process and contacting the coordinators for uploading for submitting the acceptance form and uploading the brochure, as well as immediately releasing the fund and monitoring the course program. With the first day itself, they are very much serious about all these things, and one day before we are supposed to send a web link to them, and they are putting this web link in IIT Hyderabad GIAN website, and they insisted the faculty coordinator to spread this wide web link to all the research scholars, faculty members of the department institute where this course was sanctioned. Along with that, it should be conveyed to various institutions across the world, and they also frequently reminding me as a local coordinator here also to give wide publicity to this web link, so that it should reach as many people as possible who are interested to understand the things through the lectures of a particular domain. So not only the participants who are physically sitting here, so many participants but they might have joined virtually, but you have an advantage of directly interacting with sir, not only during classwork period, after lecture sessions also you might have interacted. That is a very good option rather than attending through online. This physically attending and interacting with the professor and getting inspired from them is a very valuable contribution from both the sides. And I appreciate Government of India for initiating such a nice program for inviting foreign faculty. And successfully we have conducted, they have initiated this GIAN program in 2015, and phase 1, phase 2, phase 3 all successfully completed. We have actively participated in phase 1, phase 2 and phase 3 also. This is the phase 4 program is going on, and I already informed during inaugural session, each institution can submit maximum of 50 proposals. We also submitted 50 proposals. Until now 24 courses were sanctioned, approved, and for particularly for ECE department 6 courses were approved and fund was released, and this is the 5th course completing today. One more course is yet to be completed in the March. So all of you can visit NIT Warangal website as well as IIT Hyderabad GIAN website to know the more and more courses conducted through GIAN phase 4 across the world, along with across the country, along with NIT Warangal. So try to inform to your friends or co-research scholars or faculty members, so that they will also visit these websites and actively participate in the programs which are interested to them. I wish you all the best to all of you, and you might have spent 5 days at NIT campus. This some of you might have come first time to this campus, and this campus is having its own reputation. All of you know that NIT Warangal, REC Warangal is having its own reputation in the country, and under the dynamic leadership of our director, Professor Vidyadhar Subudhi, we are making collaboration with international universities and institutions for faculty exchange programs and research scholars exchange programs and dual degree programs. Also we are working. Definitely we will succeed in this direction and make the NIT Warangal an internationally renowned institution. In the recent past, so many foreign, I already told it during inaugural function. Now also I am reminding or informing that in the recent past 30, 40 days, so many faculty, foreign experts and faculty members visited under GIAN and Spark programs. Along with that, some other programs also they have visited, and they have enlightened our research scholars, the faculty members, and they gave a lot of international essence to NIT Warangal. So I wish you all the best to all the participants. Hopefully you may be registering for one more course yet to be conducted in ECE department. Wish you all the best to all of you. And my special thanks to our Dean Research and Development. So our Dean International Relations and IRA office looks after the uploading of the brochures and submission of the proposals, as well as other GIAN course related things. But all financial matters are taken care by this Dean R&D office. So that is a major part. We all know that technical aspects is one thing and financial aspects is one thing. So each and every rupee is accountable. So along with this course monitoring of the technical contents and course contents, along with this financial things also closely monitored by IIT Hyderabad. It is a challenging for the Dean R&D office for monitoring all the bills and final verification and submitting those things. And we are getting a lot of support and a lot of the strength from the Dean R&D office under the directions of Professor Sirish Sonevane. He is a professor in chemical engineering department. You will be hearing from his words soon about his office activities. Wish you all the best to all of you. Thank you, one and all.
Thank you, sir, for your encouragement and support. Now I would like to request Professor D. Vakla ma'am to speak few words on this occasion.
Respected dignitaries, chief guest of today's function, Professor Mohanlal Kole, Professor S. Srinivas Rao, sir, Dean IRAA, Professor S. Sirish Sonewal, Dean R&D, and our respected director, sir. Very good morning to all, very good afternoon to all. And we can see from the feedback given by the participants, the program has gone very well with lot of enthusiasm, participation from the participants. And one more thing we can say is regarding the GIAN coordinator, Farooq Hashmi Muhammad. He's very renowned person. He's conducting many programs in related to machine learning in different domains. His programs are also very attractive and many participants are interested in his other programs what he is conducting. This GIAN program is also part of his hard work what he has able to realize this one successfully. Regarding this program, actually this GIAN program, there must be one step forward. After this, we have to take one more step, lead. And our chief guest, Professor Mohanlal Kole, resource person of the GIAN program, he is very he himself is proposing to have an MOU with NIT Varangal and the university. And thank you, sir, for this proposal what you have offered to us. So we will be making it successful and we can have an MOU with the university so that we can have a long collaboration further also regarding the research or projects that we want to see further developments in this regard. And we have a very well support from the administration, like the director sir and dean sir are very supportive in handling these courses and getting all the things done time to time with very good within less time. So thank you, sir, for all your support you are offering to the faculty and to the department. And I hope all the participants, you please do visit NIT Varangal again and again as many times as possible. And we are also having the PhD programs. Maybe if you are interested, you can also enroll in the PhD programs. So where you can continue research and have a very good publications and good PhD guidance. Thank you, one and all.
Thank you so much, ma'am. Now I request Dean R&D, Professor S. Sirish Hari sir, to speak few words on this occasion.
Dignitaries on the dais, Professor Kole, Professor Vakula, my colleague Professor Srinivasa Rao sir, Professor Farooq, my other colleagues, members and participants. Actually, I first thanks to Professor Kole, getting the allocation of the not just about the time, like just coming here for not 1 week, but before that a lot of preparations are going behind. Like it might have started 1 year back also, maybe Professor Farooq and sir might have worked on that. So usually, I mean, I used to call and want to eat, we just call mother or maybe wife and says that is it ready? It is job of 15 minutes, but might be mother or wife, she might be working long day before night what has to be cooked next day. So these preparations are taking a lot of time, and these GIAN courses has really very different vision of government of India. That why we want to be it, I will tell you the story. But first of all, congratulations to Professor Farooq. It's preparation, making it into the final form. It takes longer time, and a special thanks to Professor Kole also, making this sustainability in AI, circuit and non-circuit combinations is really difficult and very important subject actually. Okay, water and energy, the next generation issues. Okay, and that's what the important area sir has bring out. Thank you very much, sir. So regarding these GIAN programs, if you look, you might have seen that how many might have visited abroad to just attend a program, workshop. Very few. Even myself, I have not attended. But here, what the government says, India has said that let us bring some of the faculty from abroad here and get exposure to PhD students as well as to the faculty. So I'm also not sure. I mean, I will have this. I'm still remember almost 55, 60 GIAN courses we have conducted. And it has got a lot of good exposure to all the students, specifically for the PhD scholar and the young faculty. This is really very important. And it was really in the Rajya Sabha also, this program, GIAN, has been appreciated. Okay, the questions and answers were there. So look to this possibility. Takeaways is very important. See, these are the small motivations, but commitment is very important. Then and then we can, achieve the excellence. So my request is take away something, and it is good thing that physical interactions are very important. Okay, so you have been interacted, I hope, and you enjoyed your campus also. See, the GIAN courses, I also attended initial GIANs, and I got lot of insightful. My students also got this thing. Regarding the R&D, I will say that Spark and GIAN, there is lot of improvements in NIT Warangal, and EC department is in the top in that all these cases, as well as for the R&D projects also. So E and ICT Academy, you look in recent faculties, they have brought some 5 crores projects also together. There is COEs are also within there. Lot of things are there. Startups, whatever you will say, the activities, they are always ahead, and I really congratulate all the faculty members. And thank you once more, sir, Professor Kole, for coming here and giving the insights of this major sustainability area. Thank you very much.
Thank you so much, sir, for your support. Now it's time to listen few words from our resource person, Professor Mohanlal Kole, sir. Please come on to the dais, sir.
Thank you very much for making a part of this GAN course. I feel very happy and delighted to share some of my knowledge with the participants. I believe that the learning from this 5-day course may be useful for your teaching and to train the next generation professionals also. I am very much thankful to the management of NIT Warangal for taking the initiative and making this successful proposal. I am also thankful to the Government of India for providing this facility through GAN program, through which the participants from all over the India can gain some knowledge related to this topic. I am very much thankful to the Dean International Relations, Dean Research and Development, Head of the Department Electronics and Telecommunication Engineering for helping and providing the platform to organize this GAN course so that all of us can get benefited. I also learned from the participants how the participants they think on the sustainability and the integration of AI also. And I am very much thankful to the director NIT Warangal for providing overall facilities for successful completion of this GAN course. I wish you all the best, and I believe that some of the learning from this course you will be in a position to implement in your teaching and to train the next generation professionals. Thank you.
Thank you so much, sir, for your valuable talks which were given in last 5 days. Thank you so much, sir. Now it's time to distribute the certificates. Now request Mohanlal Kole, sir, to distribute the certificate for the participants, sir. Sir, please.
Dr. A. Kavita. Ambati Pravalika. Yuvarani P. Mrs. Komal Mahesh Patil. Mrs. Prachi Pitam Langde.
Now I request H1 ma'am to distribute few certificates.
N. Ruchita, L. Noshin Farhat, C. Manasa, Annam Archita, Reddy Sai Prasanna, Vanita Devi R, Harun Rashid, Pritam Sheetal Angre, Thangra J, Mohammad Amiuddin Sidki, K. Aruna Manjusha, M. Anita, Dr. Pradeep Kumar Das, G. Jansi Rani, Pallavi Dhanraj Patil,
Priyadarshini,
Sheelam Rohan, Mohammad Afroz,
thank you. So I request everyone for join for the group photo. Please take your seats on the. Now I would like to invite Farooq Hashmi sir for giving the oath of thanks.
Good afternoon, everyone. As we come to the conclusion of this insightful and enriching 5-day GIAN course on sustainable AI, employing machine learning for sustainable technology development, it is my privilege to deliver the vote of thanks on behalf of Department of Electronics and Communication Engineering, NIT Warangal. First and foremost, I would like to express our deepest gratitude, our Honorable Director, Professor Mohanlal Kohle, Faculty of Engineering and Science at the University of Agder, Norway. Your sessions were wealth of knowledge and your insight into sustainable AI have greatly enriched all participants. Thank you for sharing your expertise and for your invaluable contributions throughout the course. I extend my sincere thanks to our Honorable Director Professor Vidyadhar Subudhi for his constant support and encouragement, which played a key role in success of this course. I special thanks to Professor S. Srinivas Rao, Dean IRNA and local coordinator of the GIAN programs for his guidance and leadership in organizing this course. My heartfelt thanks to Professor Siri Sonwane sir, Dean Research and Development, and Professor D. Vakula, Head of Department of Electronics and Communication Engineering, for their continuous support and celebrations. I would also like to extend my gratitude to the Ministry of Education and GIAN Initiative for their support in making this event possible. To the organizing committee and technical staff, thank you for your hard work and dedication and seamless coordination behind these scenes. This event would not have been possible without your efforts. Finally, to our participants, thank you for active engagement, insightful questions, and enthusiasm throughout this course. Your involvement has truly made this program a success, and we hope you are living with valuable knowledge and inspirations to further your work in sustainable technology development. With that, we officially conclude this GIAN course. Thank you all once again, and we wish you continued success in your future endeavors. Thank you. Thank you, one and all.
Thank you, sir. Please stand up for the national anthem.
जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल वंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
Thank you all. Please join for the group photo. I request all the participants and dignitaries on the. Yeah.
This program very successful, and they were helping Farooq a lot for this work, for experimental the tutorial classes, and they have provided lot of support. So thank you Farooq and your team, and especially special thanks to Jhansi and Priya. Thank you.
Thank you so much, sir. Like, we are really glad that you came here and you spend your 5 days of time. Thank you so much. It's a very short contribution for you, sir. Thank you. I request everyone to join for the group photo.